Okay, so I am just going to announce. Are you ready, na? Okay, sir. I'm just because I'm having some technical issue. I'm seeing. Okay, yes, we got it. Yeah. Okay. Okay, sir. একটা পার্মানেন্ট সেটআপগুলো আমাদের না থাকলে ইয়ে তো তার নাম কি আমাদের সেনাপতি এটা হচ্ছে লাইভ ঠিক
Indira ma'am, shall we start?
Mute আছে তোমার Yes sir, we can start. Mute আছে হ্যাঁ Yeah sir, we are ready sir, we can start.
Okay.
So I request all the participants also to please be on the line. Prakhar Malviya sir is going to start his session, which is very important for all of us to know about the activities and what Samarth is doing and how are we involved with it. Yes sir, you can start sir.
Okay, thank you very much ma'am. Good morning everyone. My name is Prakhar Malviya and I am Senior Manager Technical Services in National Mission on Use of Biomass in Thermal Power Plant. Respected Shri S.K. Srivastava sir, Director NPTI Durgapur, Shri Omkant Shukla ji, Director Thermal Engineering CA, Dr. Manju ma'am, Principal Director NPTI, Shri Sudeep Nath, our Mission Director for National Mission on Use of Biomass in Thermal Power Plant, Dr. Tripta Thakur ma'am, DG NPTI, and our other respected dignitaries, fellow faculty members and participants from different GENCOs, ladies and gentlemen. I am really privileged to have the pleasant task of starting this great knowledge sharing one-day online training program on capacity building on biomass pellets co-firing for thermal power plants officials with my presentation. I would also like to take this opportunity to give a special thanks to National Mission on Use of Biomass in Thermal Power Plants for giving me this opportunity to represent Samarth Mission to all of you. I am grateful to our all guests who graciously and readily accepted the invitation and joined us with great day. So to start with the topic, I would start my presentation. As you can see that our presentation is based on the Samarth, which itself clarifies the objective and the intent behind the Samarth, Sustainable Agrarian Mission on Use of Agriculture Agri-Residue in Thermal Power Plants. To start with and to set the pitch of our presentation, I would like to give it just brief about the biomass co-firing, as we all belong to a power plant sector. So I understand many of you must have already been aware regarding this, and some might be learning regarding this. So just we'll go through this in a short introduction to biomass co-firing. So biomass, any organic material that stems from plants, including algae, trees, crops, and by converting sunlight, is basically biomass. And it's estimated to contribute approximately 10 to 14% of the world's energy supply. So what is biomass co-firing? Co-firing is a low-cost option for converting biomass efficiently and cleanly electricity by adopting biomass as a partial substitute fuel in high-efficiency coal-fired boiler. To understand the potential about this biomass, I would like to tell you that approximately 230 million metric ton agri-residue is available in India as surplus. which can lead to our annual coal saving of approximately 35 million metric ton. And if we convert, it has a generation potential of approximately 50 billion units. So what's special about this biomass co-firing? First thing, that it's carbon neutral, net zero emission, enhancing climate, existing infrastructure utilization, as we don't need huge investment for utilizing this biomass, and we can start readily using in our existing thermal power plants. Greenhouse gas reductions, reduction in coal dependency, definitely anybody from the power plant sector knew about the challenges regarding coal availability. It supplements renewable sources, and definitely it's a source of income generation for farmers as well as our MSME entrepreneurs, that is basically pellet manufacturers. So biomass co-firing, in short, I have covered in the different processes related to biomass co-firing, right from the farm to factory. In the first row, all the processes are related to the pellet manufacturer, and in the second row, all the processes are related to thermal power plants. This I have already explained in the previous slide regarding its potential. That is around 750 million tons availability, 228 or you said 230 million tons surplus, 325 billion units generation. Benefits for stakeholders. So the question arises why we are talking about this biomass and everybody is taking it so seriously and we have gathered, because it's really a win-win situation for all of us, that is Gencos, pellet manufacturers and farmers. There are very clear benefits regarding this biomass co-firing. It eliminates burning of agri residue and definitely improves our environment, which is important for everyone. It improves air quality index, encourages the establishment of decentralized pellet manufacturing units, thus generates employment opportunity for revival of old age units, conforming environment norms with minimal investment, cost-effective solutions for reducing GHG emissions. Definitely there is something to take for everyone, but today's session is basically intended for our power plant producers. So I would like to mention here the benefits specifically for Genco. Its first benefit is that it's a handy solution for green energy transition. Minimal infrastructure changes requiring minuscule investment, less dependability on coal, incentives in form of higher ranking MOD, lesser carbon footprint, and considered under RPO by MNRE.
Sir, please go to the previous slide, sir.
This one?
No, sir, before one. Yeah, thank you, sir. Thank you. Got it.
So this is the market scenario at the rate 10% biomass co-firing. Total agro residue availability, surplus agro residue availability is around 230 million metric ton. And for the farmer, at the rate of approximately 1.5 to 2 rupees per kg of agro residue. The preliminary estimation says that there is a serviceable available market of value approximately 15,000 to 20,000 crore rupees. For the pellet manufacturers, the serviceable available market estimated at the rate of 6 to 7 rupees per kg of pellets is of value 28,000 to 35,000 crore rupees. And whereas for Gencos, the total potential of green energy generation is approximately 100 billion units, considered at the rate 700 grams per unit. So we can say that there is a huge potential for this market, including all this. This market have a potential of approximately 55,000 crore rupees, that too at 60% PLF. So this was all about the biomass and how does it started. So I think we all are aware that approximately 22 million tons of rice straw is burnt in Punjab and Haryana alone. And in last few years, many times we have seen that heavy pollution has been created, and with our particularly northern regions, Delhi NCR regions, got covered under the blanket of smog in month of October, November after harvesting of paddy, and which is approaching already approaching in the next 2-3 months. So it was decided to explore the possibility of use of biomass for power generation. MOP issued a policy way back in 2017 for biomass co-firing and subsequent advisory to power plants, governments by CA to promote use of biomass pellet. And finally, Ministry of Power set up National Mission on Use of Biomass in Thermal Power Plant, rechristened that summer on dated 12th July 2021 to address the issue of air pollution due to formidable burning and also to reduce carbon footprints of thermal power generation. Well, this is the background just to show you that a lot of homework and serious efforts have been put behind this initiative. So I will not go into much detail, but as I explained you, this started way back in 2017, and there was always something going on regarding this, and finally in 2021 come into a final shape with the issuance of policy. So presently, the National Mission on Use of Biomass is a 3-tier structure headed by Ministry of Power itself, having a steering committee at the top, then followed by executive committee, followed by mission directorate, which is being headed by mission director, and it have 5 specialized subgroup which are taking care of the almost every possible aspect regarding the biomass co-firing. Subgroup 1 is being headed by CPRI, which is specifically taking care for research area related to properties, public characteristics of biomass. Subgroup 2, which is being headed by the largest power producer, that is NTPC, which is taking care regarding technical specification, finalization, boiler design for biomass co-firing, safety aspects, scalable prototype, simulator design. Subgroup 3 is being headed by MOP to take care of any challenges regarding supply chain issues, logistics, and business development. Subgroup 4 is being headed by Bureau of Energy Efficiency, and they are actively working regarding the identification of labs, certification bodies for testing of agro-based biomass pellets. Subgroup 5 it's again being headed by MOP to take care regarding regulatory framework and economics of biomass co-firing in coal-based thermal power plants. So, what are the mission's objectives? Mission's objectives are like to increase the level of co-firing from present 5% to higher scales, to take up R&D activities, to address the constraint in supply chains of biomass pellets and agro residue, training of personals, whether they belong to GENCOs or farmers or our pellet manufacturer, to resolve the regulatory issues in biomass co-firing, to formulate mechanisms to provide initial capital, seed financing to encourage entrepreneurs and SMEs to establish pellet manufacturing facilities, to identify critically needed infrastructure and encourage necessary investment, to sensitize all stakeholders like ministries, departments, state governments, farmers, local bodies, agencies, etc. Preparation of guidelines, release of RFQ, RFP, other requisite documents, selections of post-institutes, agencies, signing of MAUs, release of funds, preparation and evaluation of budget, organizing meetings of expert committees, experts group, etc. So, presently there are 2 enabling policies regarding this biomass co-firing. The number 1, which is most important, is revised policy of MOP, which mandates the biomass utilization for power generation through co-firing in coal-based power plant, dated 8/10. This policy mandates that any type of thermal power plants having ball mills, or ball and tube mills have to mandatorily use minimum 5% of biomass. Generating utilities having certain, of course, the policies have many features and takes care the aspects regarding the GenCos. Some salient points regarding this policy is that policy will be in force for 25 years or till the useful life of TPPs, whichever is earlier. The minimum contract period for the supply of biomass shall be 7 years. For projects set up under Section 62 of Electricity Act 2003, the increase in cost due to co-firing of biomass shall be passed through in ECR. For projects set up under Section 63 of Electricity Act 2003, the increase in ACR due to co-firing can be claimed under change in law provisions. Obligated entities such as DISCOMs can meet their RPO by buying such generation of co-firing. Second enabling policy is regarding RPO. Ministry of New and Renewable Energy (GOI) has already clarified that power generated from co-firing of biomass in thermal power plants and is renewable energy and eligible for meeting non-solar renewable purchase obligation. These are prominent mission activities which are being done by Samarth Mission. It has issued various guidelines like revised biomass policy issued by MOP for biomass co-firing. Long-term model contract has already been issued, and I understand that all GenCos have received it. Technical assistance is being provided from time to time. Model SOPs has been prepared and issued to all TPPs for their reference. In addition to that, any issue concern being raised by GenCos regarding biomass co-firing in their TPP is also being addressed for the startup biomass co-firing. We are also doing pan-India monitoring regarding the GenCos biomass co-firing and the tendering status. Database development is the work which is an ongoing work, and under that we have developed a vendor database particularly for the pellet manufacture. Identification of labs and certification bodies, under which 9 enable labs has already been identified for biomass testing as per STM standards. In addition to that, NTPC and CPRI have taken initiative for increasing the number of biomass testing labs. Under R&D initiatives, research projects on estimating paddy content in biomass pellets and loss of GCV due to storage has already been initiated. Additionally, 8 numbers of R&D areas have also been identified under priority list of the Department of Science and Technology for further research and the development of this biomass area. Training under the training and awareness, 9 numbers of farmers awareness campaigns, 5 numbers of capacity building program for TPPs, and 6 numbers capacity building programs for pellet manufacturers has already been conducted, and 6 number capacity building program for TPP officials is being conducted today. We are also doing awareness campaigning through newspapers, advertisement, banners, hoardings in NCR and adjoining areas. Mission website has also been developed as an interactive common platform for all the stakeholders, that is farmers, pellet manufacturers, GenCos and regulators, etc. For the ease of doing business, provision of customized window for biomass pellet procurement through GEM portal has also been taken up. So, as I explained in the previous slide, a model contract has been developed and issued as a reference for all our GenCos. This was basically developed for addressing the concern of pellet manufacturers as well as GenCos to provide a common standard guideline for promoting the biomass industry. The salient feature of the reference model contract is that it's a long-term contract, that is the minimum contract period shall be 7 years. There are provisions for price adjustment on the basis of GCV. It has also provision regarding the rejection and some penalty mechanism for non-serious bidder and for the price variation. These are the few glimpses of our farmer awareness campaigns which we are doing at the farmers level. Total 9 numbers have a farmers awareness program has been conducted in association with NPTI, Faridabad, Nangal, Baghpat, Patiala, Palwal, Kanpur, Durg and Dahood for sensitizing the farmers regarding the economic use of agri-residue. 06 numbers of training programs for pellet manufacturers have been conducted at Badarpur, Nagpur, Pune, Chennai and Bangalore for creating enabling environment for biomass industry in association with NPTI. 5 numbers of capacity building program for biomass pellet co-firing for TPPs have been conducted on online mode by NPTI Badarpur, Durgapur, Nagpur, Delhi and NPTI Nammal for sensitizing the Jainpurs regarding the technicalities of biomass co-firing, and one we are organizing today in association with NPTI Durgapur. These are the progressive footprints of the biomass co-firing which have been shortly explained by our mission director also. As on date, total 36 plants have already started biomass co-firing and you can see that approximately 12 plants have started co-firing just in 2022-23 itself. So Jainpurs are coming very fast to adopt this to biomass co-firing. Progressive co-firing of biomass in thermal power plants is substantiated by the facts that approximately 82,200 metric ton has already been co-fired till date. That is last week, that is 28 2020. Progress in tendering also gives us a very positive picture that approximately 430 lakh metric ton is in different stages of tendering for not only in NCR region, in other regions also. And we can also see that for NTPC Dadri and Chhajjar, order has already been placed for 21 lakh metric ton, that too for 7 years. As on date, NTPC All India TPP's order already placed for quantity for 43 lakh metric ton. In addition to that, if we talk only about NTPC, they have approximately 243 lakh metric ton for tender for 7 number plants, which has already been floated on 6th August 22 for their different plants like Darwara, Moda, Khargone, Kodki, Solapur, Simhadri. This is the Samarth Mission website, which has been developed as an interactive platform for all the stakeholders, farmers, pellet manufacturers, Jainpurs, regulators, etc. We have also developed there some interface like MIS on use of biomass in TPPs and tender status. I think most of the Jainpurs are already aware that presently we are collecting different data regarding biomass consumption and tendering from them through different methods. But very soon they will be having this provision to update all the details in the website itself. Our website is also having features like vendor database readily available for Jainpurs. Pellet manufacturers can provide their details for getting better visibility and reach. There is update about all the policies, upcoming activities of missions are also available. Biomass usage tender status reporting can be done by the nodal officers of our TPPs. Various MIS and informations on policies. Also, there will be one section regarding the resources where all the relevant information like SOPs, etc. will be available for all the stakeholders. This is again regarding the just glimpses of the website, how our pellet manufacturers or our other stakeholders will be able to get the information. Here, our TPP's nodal officers will also have provision regarding tender detail management, actual consumption management, consumption forecast management, pellet costing management, and MIS regarding their actual consumption, tender details, costing, and these are our prominent mission achievements. Revised policy has been issued, as I already explained to you in the earlier slides. We are also promoting lending by national financial institutions for setting up pellet manufacturing units. 8 NABL labs have been identified. In addition to that, it is also being taken up with NTPC and CPRN for establishment of additional labs. Reporting and monitoring is already being done on regular basis for biomass usage as well as tender status. Issuance of model contract has already been done. Vendor database has been developed for facilitation of the biomass supply chain. Framework for online operation reporting monitoring has been developed through mission website. Research project on estimating pending biomass pellets and loss of GCB, which is a major concern for Jaipur as well as our pellet manufacturer, has also been initiated. In addition to that, we are also doing various awareness campaigning through social media channels, newspaper ads, banners, hoardings in different media. So this brings to end my this presentation. Thank you everyone.
ତମ ଏଠି ରହିବ ତାକୁ ଛାଡ଼ିକିରି ଆଇଲା ବେଳକୁ ଏଇଠି ରହିବ କି ଅଫିସରେ ହ୍ୟାଲୋ ସିଟି ଛାଡ଼ିକି ଆସିବ କି ଆପଣଙ୍କ ଗାଡ଼ି ହୋଲ୍ଡ କରି ରଖିବ ହଁ ରଖିବୁ ଆମେ ଏଠିକି ଆସିଲେ ରଖିବୁ କିନ୍ତୁ ଆପଣଙ୍କର ଏଠି ବଢ଼ିଯିବ ପୁଣି ଆମାଉଣ୍ଟ ବଢ଼ିଯିବ ଡ୍ରପ୍ କେସ୍ର ଗୋଟେ ଆପଣ ଲୋକାଲ ଆସନ୍ତୁ ଆପଣ ଲୋକାଲ ଯିବ
So I request all the participants, if you are having any questions, any queries, any other information to collect from the mission directorate, Prakash sir is there. He will help us with the information or any technical aspects, anything else. So
I think we have one query from JP Bina. JP Bina has raised their hand regarding some query.
Good morning, sir. This is Amisha from STPS. Actually, sir, we want to know about the GCB and heat value of biomass pellets.
GCB
And heat value of pellets, biomass pellets.
Sir, it will vary according to the manufacturing process as well as the raw material. But typically, we are having approximately 3,500 kilocalorie GCB.
Okay. And sir, like the if we do have an coal energy, then we get VM. Then if we think about the VM, then what will be the average value of VM in biomass pellets?
Sir, around 7 to 10%. Again, sir, we will have actually a complete technical session regarding this. So we will cover all the things quite detailed. So don't worry, means we will have our operational aspects as well as technical aspects also.
Yeah, I totally agree with Prakhar sir that we have many more sessions in which the technical aspects will be discussed, and the facts and figures along with the data and all will be shared with the participants, and we will have a very healthy question answer session also in between the topics. So now may I request Shri Omkant Shukla, the Director Thermal Engineering from CEA. Sir, are you ready to join and start with your session?
Good morning, ma'am. This is Team Mukherjee from WPT's head office. I just have a request. Can we get the copy of this presentation?
Yes, sir. We'll share at the end. We'll share to everybody. And this is already being shared. Live streaming is going on in YouTube also. So you can take a record from there, or we'll share the PPTs. No issue, sir. Shukla sir, shall we proceed?
Yes, ma'am.
Yeah.
Good morning, all the dignitaries present in the meeting. I am starting my presentation on the topic policy and regulation. I hope it is visible now.
Yes, sir. It's visible.
So my topic is policy and regulation on biomass regulation for power generation through coal firing, coal-based power plants. So as we know, in stubble burning has been cited as a of smog in northwest India during months of October and November especially every year. Farmers in northwest India burn an estimated around 30 to 40 million tons this crop waste, which is around 40 to 50%. After the harvesting season, they burn 30 to 40 million tons of their agro waste from their paddy fields after the harvesting season, and this around 40 to 50%. And this 30 to 40 million metric tons of paddy straw, which remains unutilized and burned in the northeast region only, has the potential to generate around 6,000 to 8,000 megawatt electricity and 45,000 million units of electricity annually. If it is co-fired along with coal in coal-based power plants. So, as a solution, finding solution, biomass co-firing has a potential to create a market for large-scale consumption of agro residue and convert it into electricity in eco-friendly and cost-effective manner, while mitigating problems of air pollution and generate additional income to farmers. So, this is if we see the data, so total coal consumption in 1920 it was around 620 million metric tons, and total this biomass surplus biomass is available is 228 million metric tons in 1920. And if we take just 5% of the total coal consumption of 622, it is just 31 million metric tons. Means we can see the potential how much this electricity can be produced if we co-fire, considering all the safety margins, like in the policy, we will see at present what the percentage ministry has just mentioned in their policy. So these are benefits of using biomass pellets. We use in co-firing in thermal power plants. It helps in eliminating, minimize burning of agro residue and create economic value of agro residue by promoting its use as fuel in power plants. It improves air quality, and also it creates additional income for farmers It encourages establishment of decentralized pellet manufacturing units and generate employment opportunities. NTPC already have successfully demonstrated co-firing of 7% blend of biomass pellets with coal in their Tadri plant in 2017. So, Ministry of Power in November 2017 issued policy in this regard for biomass co-firing in coal-based thermal power plants. As per the policy, all fluidized bed and pulverized coal units, except those have ball and tube mills, be it public, private, shall endeavor to use 5 to 10% of blend of biomass pellets, along with the processing technical feasibility in their power plants. And as per the policy, CA was to develop specifications for the pellets. So specifications were developed and these are available on our CA website. Appropriate commission was to determine the compensation to be allowed in tariff for increase in cost of generation on account of using biomass pellets. That is cost of pellets, increase in auxiliary power consumption and plant heat rate. So CERC has issued just tariff regulation in this regard. And as per the policy, increase in cost of generation will not be taken into account for merit order for dispatch. So that because some cost will be incurred in this and that cost will be compensated. So in merit order it should not create any problem. So it was also defined in the policy. Some committees were formed in this regard. These are the other steps taken by ministry in this direction. At technical specifications were prepared for co-firing of coal-based thermal power plant, which I have told already available on our website. In December 2019, a committee was constituted under member thermal CEA to look into the methodology for arriving at the rates of agro-residue based pellets and agro-residue in bale form, and provide indicative rates for the agro-residue based pellets and agro-residue in bales. So, the report was submitted to Ministry in July 20. In September 20, another committee was constituted under Additional Secretary. These are the step by step Ministry was doing. So, under Additional Secretary to look into the constraints in supply chain issues, and committee recommended separate separate milling system for co-firing of pellets to consider regulatory issues such as merit order dispatch of co-firing. So, in November 20, a committee was constituted under Chief Engineer of my division, Thermal Engineering and Technology Development. So, this committee was to undertake research in utilization of agro-residue in thermal power plants, including increase of percentage of co-firing units. So, the report was also submitted to Ministry in August last year. Meanwhile, MNRE also issued a notification in September 19 after issuance of MOP policy in 17. MNRE also issued notification in September 19 that power generated from co-firing of biomass in coal-based thermal power plants is renewable energy and is eligible for meeting non-solar renewable purchase obligation. So, further, in the Development Ministry revised the policy last year, and as per the policy, October 2021, utilities were to mandatorily co-fire biomass pellets in their power plants from 5 to 7%. In first year, based on their mailing system, percentage is varying. In power plants where bowl mills are there, those power plants should mandatorily co-fire up to 5% blend of biomass pellets in their first year, and in second year it should be increased to 7%. And this biomass can be which is using which is to be used in power plants using bowl mills. It can be this torrefied as well as non-torrefied. In where we are using ball and race mill power plants, those power plants have to use torrefied biomass pellets only, and in first year again.
I can't understand. Sir, can't understand about bowl mill. Sir, can't understand about bowl mill.
Bowl mill, actually, these are different kind of mills. Bowl mill and these ball and race, and another is ball and tube mill. So we can go in.
No, actually, I know about bowl mill.
So,
How I use the biomass in bowl mill.
how I use just
How
bowl
we
mill?
use?
Please come again.
How we use biomass in our bowl mill.
So these are pellets. Pellets we can use in bowl mill safely, no issue. So what kind of question? There is it is already tested. So it's a procedure. We can use torrefied as well as non-torrefied biomass pellets in bowl mill. Which kind of mill you have in your power plant?
Sir, what do you mean by torrefied?
Torrefied, it's a process by which we manufacture the pellets. So it's a kind of pellet. It is torrefied. It is an absence of just oxygen, air. Okay.
Okay, sir, carry on.
Okay. So in ball and race mill, we can use torrefied pellets. Actually, our document which is covering specifications, it is available on our CEA website. This document also covering type of biomass pellets and specifications also. Please go through that document. Okay. So another is ball and tube mill. We can use torrefied biomass pellets on 5%. And condition is also there that volatile content should be below 22% if power plant has ball and tube mills. So we have we can summarize these percentage based on the milling system as well as type of agro residue biomass pellets. So in the bowl mill, we can use torrefied as well as non-torrefied. In first year it should be 5%, second year it should be 7%, it will increase 7%. Ball and race mill, for biomass pellet should be torrefied, and percentage is in the same manner, 5% and second year 7%. Biomass in ball and tube mill, torrefied with volatile content below 22% in first year, and it should be to 5% only. And as per the revised policy, generating utilities having certain units under reserve shutdown or not being dispatched due to merit order dispatch. So they can consider to ensure to increase the percentage of co-firing up to 10% in their other operating units plants, and 5% if the voluntary mills in their other units. So also, if some plant have any genuine problem in following this MOP policy, so in the policy, one exemption committee is also there. That any power plant seeking exemption on relaxation from co-firing may be considered on case-to-case basis based on the recommendations of CEA. This committee is being headed by Chief Engineer, Thermal Engineering Technology Development Unit, and this committee comprises of representatives from NTPC, BHEL, CPRI, and the Ministry of Agriculture and Mission Directorate. Committee has to examine the request of power plants for the exemption and relaxation from mandatory co-firing of biomass, and necessary guidelines, procedures have been issued to power utilities in February 22. In other points of the policy, that policy would be both already our fellow speaker Prakhar Malvi from Mission Directorate have these points also. So again, I am just mentioning these points, important points. That policy would be in force for 25 years or till the useful life of plant, whichever is earlier. And minimum percentage of biomass for co-firing will be reviewed from time to time. And minimum contract period for procurement of biomass pellets by rating utilities for 7 years, so as to avoid delay in awarding contracts by generating companies every year, and also to build up long-term supply chain. So, other in the regulatory provisions related to tariff recognition and scheduling, projects set up under Section 62 of Electricity Act, the increase of cost due to co-firing of biomass pellets shall be passed through in energy charge rate. And where Section 62 is not applicable, that for means those projects set up under Section 63 of the Electricity Act, the increase of ECR due to biomass co-firing can be claimed under change in law provision. Means the increased cost can be recovered. And such additional impact of ECR on ECR shall not be considered in deciding the merit order dispatch. And obligated entities such as DISCOM can meet their renewable purchase obligation by buying such generation of co-firing. These are some major completed ongoing activities. Testing methodology of ready content biomass pellets have been identified. And their test lab also for identification of test lab has been done, and framework for reporting biomass pellets for co-firing on regular basis developed. Mission Directorate is just collecting the data and just reporting to ministry on bi-monthly basis, and issuance of model contract for procurement of biomass pellets by generators utilities for a period of minimum 7 years. It has also been completed. And penalty and reward schemes for thermal power plants based on prescribed percentage. This draft is under finalization. So this is a small presentation regarding policy. If any questions, please.
Sir,
Yes.
I have one question. CA has prepared a guideline, but different. We belongs to UPRC, so UPRC will also prepare some guideline for such a matter for firing of the, because we are dealing with the UPRC, and our all the billing is done in the UPRC as per the UPRC regulation. But CA has guided UPRC to do some changes in the policies, some issue of some draft regulation. That I want to know.
So actually, as per the policy, these generators they will go fire and will go to their respective ERC. So for that ERC, they have these guidelines at central level CRC, and at state level also they will prepare guidelines accordingly. Just our tech, we have prepared. Ministry has given policy that we have technically just on the fact that okay, 5 to 7% co-firing can be done, and
yes, sir. Up to now, only the NTPC and whatever the center-owned power plants have fired. Suppose state-wise we are having a lot of power plants in private sector IPPs. For that we are firing this. So if it is not UPRC is not given any regulations, then how will gain that particular and how the if it is not percolated to the downward in UPRC and UP government, then this will be a problem for the claiming on that particular firing.
See, that's actually, see, as per the policy, it is mandatory to co-fire the biomass pellets in all the power plants, coal-based power plants. And biomass mission is monitoring on monthly basis. So if any problem, please report it, and suppose any doubt that okay, how to claim the tariff,
Sir,
that all these
C and
Okay,
CRC
okay. Now
giving
the
any
question answer session is
guidelines to
going on.
respect
After that, sir, you will
UPRC
be
for
joining, sir.
the
Okay.
issuing them federation.
your concerned UPERC, you are saying UP means
UP government का जो
state
ERC
regulatory
state regulation, that's right. Yes.
Hello.
So
Hello.
you should take your query to
Hello.
means
Hello.
please co-file in your plant and
Hello.
go to your UPERC that okay, we are co-filing, and you present your case, and they will consider it. If any problem that they are not considering, then please come to the ministry.
Sir,
Hello?
if we increase the use of pellets beyond
बोलो,
5
sir.
beyond 5 to 7%, is there any
করুন।
problem in our
হ্যাঁ।
boiler combustion
অ্যালাউ করে দিই, আমার
or
লোক বসে আছে।
strategies? Means why you have stopped the limit up to 5 to 7%?
See, 5 to 7% based on the result just conducted by this NTPC in their plant, and also in other plants which are co-firing biomass pellets. So percentage can be increased as you are saying, but considering all the safety aspects, if you are finding it feasible to that you can increase the percentage, okay, no issue. But ministry has issued the policy considering all the power plants, so just kept up to 5 to 7% only.
Means actually what the other people who are already using the biomass pellets are saying. Means NTPC, mainly NTPC has started the use of biomass pellets. So what they people are saying about the use of biomass pellets? Can they have increased the limits or?
So if you notice, it is in the policy that okay, percentage of co-filing will be increased. The committee will be there, which will give you the percentage of co-filing. So at the start, see right now, if you see how many power plants are just co-filing biomass pellets in their power plants. Fine. So it will be it will be gradually increased. Right now, it is 5 to 7%.
Sir, what is the firing biomass on pollutants like SOx, NOx?
So as per the test, these are within limit. No any adverse effect of SOx, NOx on this biomass co-firing in power plant.
Any increase in limit
করে
is not
দিয়েছি স্যার, আমি অলরেডি
given
2-3
because
বার
of this
ডেইলি ওনার
biomass
সঙ্গে কল
firing.
করছি।
Because
I
we
think
daily,
it is within limit. That's why
টাইম
policy
লাগবে
is
স্যার,
for
আজকে তো
5%.
only 29
And how will
না,
this 5%
5
be
তারিখ আছে,
ensured that
আমি বলে দিয়েছি।
a particular power plant is firing 5% biomass?
You that is based on the coal consumption, that the 5% can be calculated. How much means it can be calculated based on power generation, heat rate, and all that factors, technical parameters. Okay, how much coal, and you can take the percentage. Okay, it is 5% biomass pellets I am consuming, co-firing this 5%. So based on data collected from the power plants, it can be calculated. So whenever these incentives and penalties will be in force, it will be calculated, and
Hello, madam, good
based on
morning.
that duties
ম্যাডাম
will be
ওই
in
5 তারিখ থেকে 7 তারিখ স্টিম টারবাইনের আচ্ছা
I have just
ম্যাম
got
একটু চেষ্টা
master
করুন
funda from
হ্যাঁ একটু বেশি করে
2016.
চেষ্টা করুন
One doubt I have, like whatever biomass quantity you mentioned, that is for the total
হ্যাঁ সাত
biomass of
আটটা
the
হলে
country,
একটু
or that
অ্যাটলিস্ট
only
কেন
belongs to the north
10টার নিচে
west
করতে অসুবিধা হয়
states?
হ্যাঁ একটু চেষ্টা করবেন
Please come again.
আচ্ছা ম্যাডাম আরেকটা
Northwest
কথা
what? Just please
বলছি
come again.
আপনি আমাকে
The inventory of
সিমুলেটরে
biomass
দিয়েছিলেন
that you
আগে
mentioned,
5টা
that is
তারপর একটা
generated per
কিন্তু
year,
এখন
that
7 জন
belongs to the entire
টোটাল 7 আর
country or
অ্যাটেন্ডিং
only for the northwest
হ্যাঁ
states?
তারপর
It belongs
আরেকজন
to entire
এসছে
country.
হ্যাঁ হ্যাঁ
It is
আমি আপনাকে পাঠিয়ে
data
দেবো
from
লিস্ট হ্যাঁ
Ministry of Agriculture.
ওকে ওকে
And this is the
হ্যাঁ হ্যাঁ
inventory for the unused biomass,
মানে
or
আপনি
this
আমাকে
is what
7টা
is
নিয়ে
left after recycling? Because
হ্যাঁ
biomass is
প্রথমে
also
5টা
used in
তারপরে
agriculture
6
as a fodder, it is used as a
আচ্ছা ঠিক আছে
recycled
ঠিক
back
আছে
as manure, so
ওকে
that is also done. So
It is
this is
surplus biomass. Means just uh, which is not being used. Means you are saying that after recycling and also it is surplus biomass which is not being used. So it is
but yeah, it is surplus biomass because we only have incidents of biomass burning in the northwest states. It's not a problem for the southeastern and southern states of the country. If that is the case for the entire country, if that is, then what they have been doing, the biomass till date, must be that is getting recycled somewhere.
no see in northwest okay it's a just it is being considered as major problem in south or in other parts of country. How to just dispose of this surplus biomass. So if we can consume in our
But sir,
power plant, we can
in
stay.
in the southern states, they must be doing something, no? Because we don't have any issues of biomass, excess biomass, or nuisance due to biomass. So somewhere it must be getting consumed.
So
So
no means how much know that okay means it is being disposed of in controlled manner. Just it's a better solution if we consume in power plant. So that's why policy is in fact in all over country, not in only North India. Because everywhere if in power plants if we consume we can save just CO2 consumption and also it is better for environment also. So this is the time when these all factors are just mattering. So at the world level also, so that's why policy is enforced in all over the country.
no, this is I think one way we are looking after burning in power plant because nutrients again needs to be recycled back into the soil. That is the most sustainable way how we can manage uh, excluding the northwest states. So I think we need to relook into the inventory. Actually, that is the surplus biomass or that is biomass what is left after recycling. That is the case or the entire biomass we are talking about. So,
See,
those
just actually yes, enough surplus biomass is available in the country. So we are talking about surplus biomass only, and surplus biomass means it is as per the data you see it is 250 million metric ton as Srinath sir was telling, and so if 5% is only 30 million metric ton only. So if we consume that, in other you are saying if we have to dispose of like in earlier we were disposing that way we are disposing that. So at this biomass we can consume. So okay we will save emissions, CO2 emission, all that. So this is a good initiative in that direction of municipal power.
but why it cannot be used in cement kilns? They could
Why?
be even better off cement kilns.
It is as per policy, cement also they have plant and they have to use in their plants.
Okay. Sir, Piyush from Maruti Clean Coal and Power, we have sought exception from this biomass firing in our unit on account of availability of biomass. Actually, we have issued and released an NIT for procurement of that biomass, but in Chhattisgarh region, we are not having any
expression of interest for this biomass supply. So what we have received from this mission that submit a technical feasibility study along with your OEM. We would like to mention that technically we are not having any issue in firing the biomass because we are having a ball mill. We have developed the logic also for the biomass firing. But what we are facing only the availability. As your this slide shows that the actual requirement of biomass is somewhat 4.65% ton, 4.65 million metric ton per annum in Chhattisgarh, but the availability is half of the requirement. So we would seek some help regarding this. Either we should be exempted from this biomass firing, or we need some help in supply of the biomass.
Actually, just to address this issue, Biomass Mission has 5 specialized subgroups, and one subgroup is especially to deal with the supply chain issues. So, yes, your request of exemption has already been taken, just taken by Biomass Mission, and that subgroup 3, which is for supply to address supply chain issues. So that subgroup is taking up your matter. So accordingly,
Sir, the second point is issuance of model contract. We have not been shared model contract for 7 years supply. Can you please help me with that?
Yes, actually, all the representatives from Biomass Mission are also connected in the meeting, and just please, they are also listening. So, please contact. They have Mr. Prakhar has also given his mail ID. Please contact Biomass Mission, and they will share with you.
Okay, sir. Thank you very much, sir. Sir, when this policy had to be implemented?
Please, 2 voices I couldn't get you. Please come again.
What is the timeline by which this policy has to be implemented? Biomass 5% blending.
It is in force since issuance of the policy, means 8th October 2021. Means we are no need to wait when it will be effective. It is in effect since 8th October 2021.
So now that every power plant will start because this policy is being implemented.
Yes, as per the policy, it is mandatory, and every power plant has to start co-firing biomass in their.
How will the cost of pellets be regulated? Who will be the regulating authority? And what is the difference from the coal price?
Coal price. So this the model contract and means you will get a price, and whatever the price it can be claimed. Whatever your expenses in co-firing, that can be claimed.
This is Anish Shukla from Adani Dhanupur Power Station. We are in touch with several vendors for supply of biomass, but whatever we have is the data, moisture content is around 60 to 65%, whereas the slide was 22%.
For unit setting, volatile milk.
Yeah.
Yes, okay.
The volatile matter, what the conditions we have received is around 65%. Recommended 52%.
So your issues is similar like Maruti clean coal. So if you have this problem, which is related to supply chain, so your matter also will also be taken up by subgroup 3.
Okay, sir. Thank you.
So we had a large of questions, and we thank Shri Omkant Shukla, the director from CEA. Thank you so much, sir. And I think so that the session was quite lively and interesting. And now I would like to invite Shri Rohit Grover, manager from NTPC Dadri, who has his wide experience in the biomass co-firing experiences and the combustion practices also. So Mr. Rohit Grover, over to you, and you can start your presentation, sir.
Is my presentation visible? Thank you so much, ma'am. Is my presentation visible?
Not yet, sir.
Okay, right. Is it now?
Yeah, now it is okay, sir.
Okay, thank you. Good afternoon, friends. I'm Rohit Grover. I'm here to share our views when we actually fire biomass in boiler. So what our today's topic will be regarding co-firing of biomass pellets and what are the operational challenges, what are the challenges which we faced when we fired biomass for the first time, what were the apprehensions which we had, and how we take up that apprehension with our research wing, and also how we look forward in the future. We know that biomass co-firing, it all started taking the heat when there was a large smoke in Delhi that led to the thinking of brainstorming of all the think tankers that what should we do. Then it was decided that we need to have a disposal mechanism for biomass because it is going to create a huge problem, leading to huge pollution in areas like Delhi NCR. So our today's topic presentation highlights will be discuss about some background, we'll discuss something about first phase of trial operation, what is the operational experience of NTPC Dadri, and what are the requirements which are necessary before we go for commercial, and what are the SOP for biomass co-firing and way forward. First of all, just I'll take 30 to 40 seconds over this. Why do we call biomass is a clean source of energy? Because whatever biomass we are going to burn, the carbon dioxide released from burning of that amount of biomass will be captured again by the plants in the form of photosynthesis, and then again it will be converted to biomass. So this is a natural cycle which is going on for biomass. That's why we consider biomass as a green fuel. Because whatever we are going to burn, the carbon dioxide release will be captured again, and then it is not leading to any extra CO2. So that's the data which we all know, nothing much. In 2017, what we know, I'd like to share is that NTPC Dadri was identified as a pilot project for implementation of co-firing of pellets with coal. Now, prior to this co-firing of any biomass pellets, we knew that as an operation engineer, I have worked in operation. There is a lot of apprehension whenever the fuel is changed inside the boiler. So every with the change of calorific value, with the change of the mines, with the change of anything which is going to change the fuel, which is I'm going to fire in the boiler, it definitely affects my parameters. So firing a altogether new fuel in the boiler for the first time was also an apprehension task for us. And in this task, our research wing later helped in us. So what they did was, whatever the biomass pellets which we got for the first time, they were tested in the lab, and whatever the specification which we need to give to the supplier, that okay, your pellet should be of this size, of this calorific value, and it should be made from this. These were the specifications which we provided to the pellet manufacturer. And in the NTPC Dadri plant, we developed operational procedures as per the results which we get from the Netra when they fire that biomass in their testing boiler. So we started with, first of all, we started with co-firing of 100 metric ton of pellets for 210 megawatt. Dadri has 6 units. So we are firing biomass in 210 megawatt units also and 500 megawatt units also. We have started with 5% blending and then till 7.5% and 10%. We have also fired 10% blending and then we have tested it for a whole day, and I will also share the results with all of you. This is a normal picture how the agro residues to co-firing, which we all know that if farm residue is collected, it is converted to bales. This is called baling procedure, and then it is tagged and it is sent to the manufacturer of pallets. And from pallets, it reaches your power plant yard, from coal yard, whatever the arrangement is there. Then from there, it is sent to your bunker for firing off along with coal.
In NTPC Dadri, there are bowl mills, so we have experience of co-firing your pellets along with your coal in bowl mills. So these are the basic technical specification which we provided to the pellet manufacturer. Now, the moisture content something which we have to look for because it is a hygroscopic content. It catches moisture from the atmosphere, which we have to take care of also. Now, when the chemical analysis, approximate analysis of this biomass sample was done, as you can see that volatile matter in the biomass is high. It's around 67% as you can see in the sample. It will not be the same figure for every biomass, but that is quite clear that the volatile matter which we are firing in India, which we are finding in Indian pool, which we are commonly firing in our boilers, is around 22 to 25% of volatile matter. But the biomass has 67% of volatile. So that was the major challenge for us. How should we tackle this biomass volatile matter? Volatile matter is something which helps in burning. It is a first thing which basically releases from the burning process. When we see the combustion process, there is a step called devolatilization. Devolatilization is the step in which the volatile matter present in the fuel is released in the boiler. So it starts the firing. So that is something which we have to do. Now, as you can see, like this is the first row is for 100% coal and the last row is for 100% biomass. So if I'm going for 5% blending, volatile matter is going to increase to 22 to 24% around, and with 10%, sorry, this is 10%, that it goes to 26%. Similarly, the ultimate analysis was also done. As we can see, the more or less it is just same. The sulfur content in the biomass is less as compared to Indian coal. So one of my colleagues was asking, is there any effect on SOx-NOx parameter? SOx-NOx parameter doesn't affect much because they almost remain in the range itself. And whatever the benefit we get in SOx, there will be slightly lesser SOx with biomass coconut. I would say only slightly lesser because it won't be possible to measure even in the instruments, or sometimes you can see the results, but definitely you can conclude that because of this we are getting the lesser SOx. So SOx parameters remain in the limit. Now, we know that wet biomass leads to sticking in the mill, so we have to be very, very clear that biomass needs to be dry when we are grinding in the mill. Because wet biomass, what it is going to do is it is going to stick around your grinding surfaces, and it is not going to lead into your proper grinding of fuel itself in the mill. Now, this is just a comparison which we have seen in the previous slides also. One more thing which we need to see is that the ash fusion temperature of this bituminous coal is around 1300 to 1400 degrees Celsius, and for paddy straw it's around in the range of 900 degrees Celsius, which we'll see how it is going to affect. Now, the combustion analysis of the Netra team, our research team, which we did in their boiler, basically when they fired a sample of 5 to 10 grams of the mixture, they found that the volatile matter of the coal, it releases at around 300 degrees Celsius. We know that when we burn coal in the boiler, we carry coal with the help of hot air. The purpose of hot air is to remove the moisture so that when the coal reaches the boiler, it is ready to be burned, basically. But in case of biomass, the volatile matter start releasing from around 200 degrees Celsius. 210 degrees Celsius, the volatile matter start releasing. So we don't want that the volatile matter should be released in the coal pipes, the pipes which are carrying the fuel to the boiler. So that is a constraint which we have to keep in mind, that the biomass devolatilization is happening at 200 degrees Celsius. So whatever temperature I need to keep of the fuel, I need to keep it less than 200 or 210 degrees Celsius, which we'll see whatever the modification which we have done. So when we were fighting for the biomass for the first time, we made sure that the mill inlet temperature should be less than 180 degrees Celsius. When we say mill inlet temperature is nothing but the mixture of hot air and cold air which is used to carry the fuel to the furnace. The temperature of that air should be less than 200 degrees Celsius. That specifically we decided that it should be on the safer zone. We should keep it at around 180 degrees Celsius. So whatever the alarms were provided, whatever the protections were provided, they were provided keeping this in mind. We don't want our mill inlet temperature to go beyond 200 degrees Celsius. There were protections also. If by any due to any problem the temperature goes above, my hot air gate, my hot air which is going to the mill will stop. So these are the protections and alarm enunciation which were also provided. And the biomass co-firing, as we had apprehension that the biomass burns faster with respect to coal, so we decided to fire it for the first time in the middle mills. So if we are having 6 mills, I decided to fire in around C, D, E mill. If I am having mill from Agra to Farakka, Agra to F, sorry. Next is expected higher water vapor temperature. We were thinking that when we are firing biomass for the first time, we were expecting the water vapor temperature to be higher and superheated temperature to be lesser, because biomass is going to burn in the first pass earlier itself. So these were all the out of this first we were short, second and third we were apprehension because we were firing for the first time. So what were the test results that we'll see in the meanwhile. Then also there were some 4 additional temperature points which were provided in the coal pipe, which is going to carry the fuel to 4 different corners of the elevation. Suppose this is a pictorial diagram of any mill. The mill is going to pulverize your fuel and it is going to carry with 4 different pipes to the burner. That 4 different pipes were provided different temperature points, so that we get to know that if their temperature point is going any high or lower, we will get to know that if any sedimentation is not happening, if there is only no residual is happening, the flow in the pipes is normal. Also, one additional thing was given was motorized inerting wall. We know that when we fire fuel for the in the mill, the fuel mill is designed that in case of any fire, that mill fire is quenched with the help of steam. Steam is entered into the mill to quench any mill fire if any it happens. Earlier in NTPC Dadri, the arrangement was only the manual valve was there. So the modification which we did in the power plant was we provided one additional motorized valve in the series. So what would happen is that if any parameter is going to deviate, if I am going to get to know that my mill is in fire, I can open it from the control room, sitting in the control room itself, so that I can quench the fire. That was one additional feature which was done in the modification, in the physical modification, I would say that. These 4 transmitters you can see and the inerting valve which was additionally provided. Then whatever sample used to come to the NTPC Dadri, it was tested for moisture tested, and there was a coherence between different departments, whether it is chemistry, whether it is your coal handling department, fuel handling department, or your operation, that as and when the consignment reaches the plant, it was tested in the earlier manner, in the fast manner as and when we get. And the CHP used to do is that it is used to send it to the bunker itself. Because when we were fighting for the first time, we didn't have any storage area. So as we know that if we are keeping the pallets in the open atmosphere, it is going to catch the moisture, and then it is of no use to us.
Sir, I have a question.
Yes. Please go on.
ఒక్క నిమిషం ఉండి మీ ఒక్క నిమిషం.
Why we use it in C, D and E mill? Why not in Agra or?
I'll just come to it. Let us just finish the
Sir, I would request the participants, please have some patience and let us go with the presentation. Maybe your answers will be there in the succeeding slides also.
When we started for the first time, we started with CDE mill because we were apprehension that the biomass will burn if I'll burn in the fire in the bottom mill or in the top mill, because in the bottom mill I had a chance that whether it will lead to increase unburned carbon in my bottom ash or not. That was apprehension, but right now in every mill we can fire. So just to answer your question, in every mill you can fire. That CDE was written, it was given a scenario when we were firing for the first time. So we had all the apprehension that if let's fire for the middle mill, then it is not going to deviate any major parameters.
మార్చేస్తాం.
Okay, sir.
అయితే మనం వెళ్ళి combined
The
గా
coal
తీసుకుందాం.
blending was done. We started with the blending because there was no proper blending mechanism. So when we say 5% of the biomass, we need to fire along with this. What is 5% biomass? Let's just give it order of time some out there. So suppose if my coal is running at 100 tons per hour, I'm firing 100 tons per hour, then my 5%, 5 tons should be biomass from this. Now that 5 ton of biomass can be present in 2 mills, can be present across all the 4 mills, whatever it is running. So when we got it for the first time, even when some new station, when you will get the biomass for the first time, you will start firing with one bunker. You will not fire biomass in all the unit, all the mills at once. Okay? You will start with one mill, then you will see the observations, how your boiler is at, how the major parameters are there. That's the common layman procedure how we start with biomass profiling. So there was a track hopper and reclaimer hopper, and there was a common transfer point. That's just a block diagram. Since we didn't have the arrangement earlier, what we used to do is that we used to mix the biomass along with the coal with the help of some, you can say, plain kind of arrangement. But now we have a reclaim hopper. From hopper, you can see this. These are the hoppers. The biomass is put over there, placed over here, as you can see. Now the biomass is then with the help of conveyor. You can see over there biomass feeding for blending. This is the biomass transporting it with the help of conveyor. And with the help of any rack and pinion arrangement, we used to have an estimate of 5 to 6% of blending. So these were some of the parameters which we were keeping in mind, that how our boiler is going to affect the performance. What are the unburned carbon? What are the effect of co-firing on my SPM, my dust particulate, my SOx, NOx, and whether it is leading to any my fly ash evacuation time or my bottom ash is going to increase the time. That was also monitored. And the mill rejecting classifier also was checked after the definite interval that we have planned, that if we are going to fire for the first time, we'll fire it for some time and then we'll take the mill permit, whatever mill in which we are firing, we'll check the internals of the mill, whether it is going to any residue, it is getting stick to the mill internal surfaces or not. So in 2018, we started biomass co-firing for in the commercial way. When we say commercial, we used to pass the cost to the beneficiary. We used to take the cost from the beneficiary. Then we started in 2017 September, and from 5% till 10%, we have fired it all. And we, on our experience, we can say that it is perfectly safe to fire till 10%. But since there were apprehension, it's one question I also got to know from this: why only 5% or not more than 10%? Because we'll start with some lesser parameter on a safer side, 5%, and then we subsequently increase it to 10%. But our research wing definitely doesn't want us to increase to more than 10 to 12%, because we have seen in our test that when we increase the biomass percentage beyond 12%, the stickiness of the biomass leads to deposition of soot inside the boiler tubes. Till 10% is fine. It is not going to hamper it. Whatever soot is getting deposited is loose in material. It is not going to stick. Whatever we can remove it with the help of ball blowing, which we do, or the LRSB, which we do, it is not going to stick. But beyond that, it has other issues also, which we don't want. So in 2020, 500 megawatt units also started commercial co-firing of biomass, and in all the 9 mills of stage 2, basically 500 megawatt, and all the 6 mills of 210 megawatt, they are all ready for biomass co-firing. So we have seen the modification which we have done in the physical form. The mill inerting motorized valve was provided, and some 4 temperature transmitters were also provided. Now, what we did on the logic part, we will see over the logic part. I don't know how means there's something related to an operation or CNI person. If anyone present in the meeting, they'll understand it that we carry hot air and cold air, mix hot air and cold air, and then we get it to the mill. They carry the cool, it takes it to the furnace. I hope it is clear. But when we are firing coal for 100% coal, what are we monitoring? Basically, we are monitoring the mill outlet temperature. Suppose the hot air temperature which is entering the mill is around 260 to 80 degree. The mill outlet temperature I used to maintain out 75, 80, 85 depending upon the coal quality what I am getting. So what it is happening is, as you can see in the logic, there is like hot air damper and cold air damper. So cold air damper used to be, if the outlet temperature is going to increase, it used to open more and hot air damper will decrease so that the outlet temperature decreases. So there are two things, hot air and cold air. So if the controlling parameter is outlet temperature, if it is going more, cold air will go increase, my outlet temperature will decrease. If it is going less, my cold air will close and my outlet temperature will increase. That's the process which 100% coal firing which we used to do. Now, if we started up, suppose if I'm putting my 1 mill into biomass mode, then biomass mode used to be, it used to monitor the mill inlet temperature. As you can see over the right side, there are two temperatures, mill inlet temperature. These mill inlet temperature is a mixture temperature of hot air and cold air which used to be present. I don't want it to go beyond 185, 190 degrees Celsius. So what I have done is that I have asked my cold air to control this temperature itself. That's the basic logic modification which any present at any maintenance engineer, logic, CNI, controls and implementation engineer can do it on their own. So for the beneficial for operation engineer, that if we are firing any mill for the biomass mode on, what we used to do is that the cold air damper is going to see the logic of my mill inlet temperature. So it is going to maintain mill inlet temperature of around 180 degrees Celsius. These are the basic effects which is led to if we are firing for the biomass, firing biomass, we have done the result efficiency wise that it leads to increase in flue gas exit temperature definitely because we are using lesser. So lesser hot air means I am not extracting the whole temperature of my flue gas. So in the air preheater, so it is going to lead to increase in my flue gas exit temperature. A slight increase in mill power consumption, a slight decrease in boiler efficiency, slight unburned carbon also increases, and there is decrease in unburned carbon on fly ash also. So it is more or less compensated. This is the overall, this is a truck tippler. First diagram shows the truck tippler which we have designed in the NTPC Dadri. The whole consignment used to come in the truck and then we can just tipple the truck and then unload it, and then with the help of reclaim hopper, we used to carry in the conveyor, and this is the arrangement. The opening of this wheel will lead to more biomass being fed over the conveyor below, and this is the mixed biomass which is going to the bunker itself. This is all the pictures. This is a different biomass storage which earlier we used to cover it with the help of to prevent any moisture going. Now a shed of this kind of arrangement has been made at NTPC Dadri. But I assure you, as soon as we get the biomass, we fire it in the bunker itself. We hardly store in the yard for this. This is the data of biomass co-firing what we have done till January 2022. This plants which we have NTPC Dadri, Jhajjar, even now Moda also have done this. So we have Uchahar also have started firing. These are some of the benefits of the biomass co-firing, which we all know that if we are going to definitely, if we want something to go 5% co-firing along with the coal, then definitely it is going to lead to the more economic activity, the lower SOx parameters, SPM also lower, and we'll also have lesser dependency on coal because our 5% will be met by the biomass itself. And when we go for pallet manufacturing and all, it is definitely going to increase the employment generation, and it also leads to carbon emission mitigation, which we have seen in the first slide, how burning the biomass doesn't lead to greenhouse gases. Thank you so much. I'm open for questions.
When you are firing the biomasses, then will outlet temperature will be the same 65 degree or 70 degree, or it will just come down?
The mill outlet temperature will definitely come down, but just a second. The mill outlet temperature will come down because we are keeping the mill inlet temperature around 180 degrees Celsius. So we generally keep the mill outlet temperature around 60 to 55 to 60 degrees Celsius, because how do we keep that? We keep that with the help of keeping control in the feeding. We decrease the feeding of the mill.
Sir, hello.
Yeah.
Sir, being an operation engineer, if we keep mill outlet temperature, mill inlet temperature less than around 200 degree,
Yes.
it is possible to control the temperature, because in a mill moisture is around in a coal moisture around 14%.
Yes.
So if we go less than 200 degrees, it is very difficult to control the mill outlet temperature.
Mill outlet temperature, if I'm right, let's suppose if I am firing a mill 100% coal, I am firing, suppose example, 40 tons of coal. Okay, 40 tons of coal and 260 degree inlet temperature, my outlet temperature is around 75. That's the basic parameter which we get when we fire the coal. Now, if we are firing the biomass along with the coal, suppose 5% blending or 10% blending, it is going to lead us, my mill inlet temperature will be 180 degrees Celsius. Now, I don't want my mill outlet temperature to go very less, because it will lead to stickiness deposit and it will not lead to the moisture separator. What I'm going to do is, I'll decrease my mill loading from 40 tons to 30 tons, or somewhere around जिससे मुझे mill outlet temperature मिल जाए. Is it okay? Right?
Yeah, but outlet temperature will reduce to 50 degree as per my experience with if I have to control that.
Not 50. If 50 degree है तो आप थोड़ा दो तीन टन और कम कर दीजिए 55. This is something which an operation engineer knows that what he needs to do. It will decrease the feeding. या एक extra mill लेना पड़ जाएगा. बस ये हो सकता है.
Sir, I'm an operation engineer. I have a query.
Yes.
Sir, as of now in my plant, I have only 1 mill in standby condition. So as you told, I'll be using this pellet and will be reducing the coal from. I'm running the mill at 80% of loading, not 100% loading. I'm running the mill at 80% of loading. So as I'm using pellet, I'll be running the mill from 80% loading से 60% loading तक मैं कम करना पड़ेगा ना. So I was supposed to take my standby mill. So I won't be having any such एक्स्ट्रा मिल फॉर मी. स्टैंड मिल मेरे पास और कुछ स्टैंड मिल नहीं रहेगा. पॉइंट नंबर 1. और पॉइंट नंबर 2 है, मैं शटडाउन के लिए दे नहीं पाएगा, पीएम के लिए दे नहीं पाएगा, और कोई शटडाउन वर्क नहीं कर पाएगा, कोई जो भी परमिट्स जो भी डिफेक्ट्स उसका अटेंड करने के लिए मिल दे नहीं पाएगा. दिस इज क्वेश्चन नंबर 1. और क्वेश्चन नंबर 2 है, जो रेनी सीजन में जो कोल मेरा का आ रहा है वो दैट इज फुल ऑफ मॉइस्चर, मैं स्लरी जैसा आता है मेरा का, उसे मैं जल के मैं करने में बहुत मुश्किल पड़ता है मेरा. उस टाइम में ऑल मिल्स विल बी केप्ट इन सर्विस. ड्यूरिंग दिस टाइम मैं पैलेट को यूज करने का practical difficulties will be there, na? These two questions I need your answer.
Yeah, Pradeep, let's be very clear. When it's monsoon season, there is already a shortage of biomass also. Suppose so, let's say sure in the monsoon season, your biomass also will not be reaching the power. That's the difficulty which we face. This is the last question answer. Now, regarding let me just answer. We can ask later. Now, regarding TM, different power plant behave differently, different boilers, different mills behave differently, more or less. We have seen at times when, suppose I have a 210 megawatt unit, my full load comes at around 4 mills. I have 6 mills, my 4 mills are sufficient for full load. That's the quality of coal which I get. So, if suppose I have seen if there are biomass in 4 mills, that is a rare chance, Pradeep, because you will get biomass in that much number that you will fire biomass in all the mills. Okay? Because suppose if I am getting the biomass, I will go for one unit. Mostly what we are having is we are having different units. Suppose in my unit, in my station, I have 6 units. So if I am getting the biomass, I will give first target one bunker of one unit, then second I'll target the second unit bunker, then I'll target the third unit bunker, then I'll target the fourth. Similarly, Goa. If I'm getting more biomass, then I'll go for 2 mills in 1 unit. Similarly, this kind of thing. So what we are talking about is very in future, when we are getting a biomass in that much amount that we are firing in every mill. So that's something which we have done as a test project in Dadri, which we have also done, and we have got the load in 4 mill itself. So it's not an issue. Suppose if it will come, you can get your PM schedule because your 1 mil can be there. Not always you need to start your standby mill. Is it okay? Fine?
Yeah. For my first question, as you told, you're using 4 mil. In my case, earlier I was using imported coal. During the time, I have 2 mills in standby condition. Now I'm using Indian coal. In Indian coal GCV and calorifical is very less. So मैं अगर supposed to take मेरा coal flow बढ़ गया इसलिए मैं और एक मिल लेना पड़ा. So मेरे पास अभी एक मिल सर standby में है. If in this case if using pellet, then मेरा condition मेरा coal flow और मेरा coal flow कम करना पड़ेगा तो each mill में तो फिर मेरा load generation कम करना पड़ेगा मेरा का. I have
No, you don't need to keep your generation down. That is quite clear. We have seen in the operation. हमें तो लग रहा है कि इससे मिल का कैपेसिटी बहुत नीचे आ जाएगा. ऐसा होगा नहीं. Just see it over here. आपको लगेगा कि जो हमारा safer zone हम जैसे सोचते हैं कि suppose we need to keep the mill outlet temperature what should I say above 60-65 degree. No, with biomass you can go a little bit lesser temperature. So that an operation engineer expertise, I would say that वो ठीक है कुछ उसको कम करेगा दूसरी मिल में बढ़ाएगा कुछ कर देगा उससे वो ले आएगा उसमें एक because if you will fire for the first time you will fire only in the one mill. Okay.
No, I will give you an example. In my plant, I'm using inlet temperature 270 degree and outlet temperature I was maintaining 62 to 65. Not more. I'm not getting more than that. Inlet temperature of 270 or 290, I'm getting only an outlet temperature of 62 to 65 maximum. So I'm using pellet. Then my inlet temperature is getting reduced. So outlet temperature obviously reduced. It will get much reduced.
आप एक बार start करेंगे अगर एक मिनट को fire करना, then you will get to know the actual conditions which you are getting. Because in our power plant, we used to keep the mill inlet temperature around 270 degree, and we used to get the mill outlet temperature around 75 to 78 degree. That more than that, and there was also.
Hey, good for the moisture and GCV.
Yes, that's correct.
Okay.
You said that 62 degree.
Okay. Coming to the question number 2, how you will be supplying how will be getting the pellet throughout the 365 days? As you told, you will be getting only during harvesting season, but how you will distribute it throughout the year equally?
You are asking the wrong question from the wrong guy because I'm not an expert in the supply chain.
You are using it for last 2 years, so easily I am asking you. So are you getting 365 days a year?
No, we are not getting 365 days a year.
Yeah.
Sir, I have one question, sir.
Yes.
Has NTPC faced any fire problem in mill after firing?
No, not yet. Not yet. Definitely.
Sorry, what are the precautionary measures you have taken during the firing of mill? Apart from the fire tender and all those inert gases, any others which we need to focus during the firing of biomass?
Nothing, just the vigilance. There are some enunciations extra which you can provide in the control room with the help of CNI engineers. Like if my mill inlet temperature is going beyond, I just told that mill inlet temperature should be kept around 190 degrees Celsius. So the operation engineer needs to know that my mill inlet temperature is going, whenever it is going beyond 195 degrees, some enunciation should be there. It helps in timely action of the power plant engineer operation. Also, you can have the logic that my hot air will get close at around 205 degrees Celsius to prevent any mill fire. Definitely, we have seen in our power plant that no fire incidents usually happens. With 5%, 10%, it is perfectly safe to go fire. Please be rest assured of this.
Okay.
So hello. This is the confidence which we are getting when we start firing the biomass, because that's the confidence which we also got earlier. Whenever the biomass used to get fired in any unit, the fire tender used to stay below the boiler of that specific unit. Okay. But over a period of time, we got to know it's fine. We need not to call fire tender every time. So that's the experience which we'll get when we'll start firing.
Hello, Mr. Rohit.
Hello. Yes, sir.
Rohit, I'm Hari Solanki, and my question is that we are firing imported coal, and that is having the moisture content is around 35%. So we, to maintain the outlet temperature, our mill inlet temperature remains around 250 degrees centigrade, and then only we get the outlet temperature 50-55 degrees centigrade. Then with the mixing of this biomass in imported coal having higher moisture, how to maintain the temperature below 200 degrees centigrade? Have you gone this type of issues?
तुम्ही नाम द्या.
When we have fired this biomass with imported coal also, but not 100% imported coal.
राजीव कुमार तो
In Dadri, there is no
चेतन कुमार.
Indian coal is being fired. So definitely the question which you are asking, we have not done it actually. If you have any doubt regarding this, then you should basically contact our Netra wing so that you can send your coal sample and the biomass sample. They can test it, then we'll let you know. Definitely, if it is 50 degree with the 250 degree and your whole imported coal is there, it is a difficult thing.
It is a total imported coal, and plant is also designed on 100% imported coal.
Definitely. You should consult our technical team, then they'll test the coal sample along with the biomass sample. But definitely, as I have suggested to other my fellow members also, that if possible, if there is a you start taking one extra mill and then start co-firing with the biomass, and feeding should be kept less so that my mill outlet temperature at least should be above 50 degree. You are still firing at around 50 degree. How much is the outlet temperature which you are getting?
50 to 55 degree.
50 to 55. That's the bare minimum which is required.
Which is required, and that we are able to maintain when we keep the inlet temperature 230 to 40.
Fine. Mill inlet temperature, there cannot be any compromise on mill inlet temperature, which we have seen over there in the test. So better, Solanki ji, better to consult this Netra wing and then test your sample regarding this, so that we can see how it is going to behave. But in the Dadri, we have fired your imported coal, but not in 100% imported coal manner.
So in Dadri, when it is fired with imported coal, so that biomass was mixed in the same mill where the imported coal was firing, or that imported coal was
I suppose, if I am getting my imported coal, my plant is not designed for imported coal. It is designed for Indian coal. If I am getting imported coal rack, my CHP used to do is on that, like suppose if 10%, 20% blending of imported coal is being done with my Indian coal. Is it okay? Right? Now the coal which I am getting is blended coal. Again, I am increasing the blending by increasing this biomass. Just a sec. Hello.
Name
Hello.
not there.
Hello, sir. My name is Amit, sir. I'm speaking from JP Bina. Sir, actually, our boiler has a tendency of clinkering, sir. If we utilize this biomass firing, what can you guide us? How
Amit, can you please ask the question again?
Sir, our boiler normally has a tendency of clinkering, sir. We continuously operate food growers every 8 to 10 hours.
Okay.
So implementing this biomass, what is the effect on furnace in regard to flagging and clinkering?
Whatever the clinkering which you are facing right now, if you are facing right now, is due to any combustion, it is biomass co-firing is not going to increase it. It is not going to increase the clinkering definitely. So rest assured of this, because which we have seen in the test parameters also, till 5% to 6%, 7%, it is not going to increase any clinkering. Okay? Right?
Sir, sir, हमारा एक रिक्वेस्ट
This is services द्वारा
একটু আপনি
actually
आपके रिक्वेस्ट করলে কোন একদম নেক্সট ই আপনার স্যার একদম নেক্সট ই আপনার কোশ্চেন আনসার চলে হ্যাঁ
same follow
এই তো ওই তো না না সেটা সবাই এনটিপিসি আজকে কিন্তু রোহিতের তো সব কোশ্চেন আনসার শেষ হতে এসছে স্যার তো আপনি এখন 15 মিনিট আগে হলে আমি সবাইকে রিকোয়েস্ট করতাম এখন টাইমই নেই
Sarveshwari, your voice is breaking.
অ্যাডজাস্ট করে নিন না হ্যাঁ ঠিক আছে 15 মিনিটে শেষ করে দিন ঠিক আছে স্যার ঠিক আছে ওকে ওকে নো ইস্যু ঠিক আপনার তো হাফ এন আওয়ার আছে আপনি যত তাড়াতাড়ি আপনারা কমপ্লিট করে দেবেন ঠিক আছে ठीक
I think so कि
okay sir
we will get that much
Obviously, you will not get. Sarveshwarji, you will not get the outlet temperature which we have in our mindset regarding 100% coal. And with 100% coal, if we are firing Indian coal, we definitely keep around 75 degree, 78 degree to increase the efficiency part. I hope, this is fine. Definitely, we not get that much temperature with this biomass. We need to have our acceptance below that, whatever temperature around, but not below any. I wouldn't suggest below any.
Yeah, the problem that is, we can run at 7 minutes. We can, if I want to increase the, तो ultimately मेरा एक जो मिल का जो ऑक्सीजन पावर वो बढ़ जा रहा है. वो भी
Definitely वो बढ़ जा रहा है. Definitely, Sir Vishwa ji.
Yes.
When I talked about the efficiency part, the milling you would say power definitely increases. That is something which we have to see, keep in mind. Definitely, वो थोड़ा बहुत affect तो करेगा ही. But we can start firing. Then whatever your feedbacks are there, you can share with the National Biomass Mission. Whatever whole station will say, share the feedback. But then
I
definitely
think already we are there. Our DB power already there in national power. Already we are there in that one. Mission power already we are there in that our total PPTs. So about whatever getting the problems and everything. So one more thing is
excuse
that
me,
if
sir.
you 5
Sir,
to 10% of
I just
biomass.
take a break here, sir. Sir, excuse me. We are having a question answer session just after this because our next speaker is having some urgency. He is also in the field, so he has requested me to allow him to continue with his presentation. And after his presentation is over, if time permits, before lunch we can have a small question answer. Else we have enough time again in the post lunch also. I would request the participant, please keep your questions ready. We will take it after the next presentation is over. So I would request, I thank Rohit sir. And sir, please be online because you will be getting the questions again. I assume that the questions are not complete yet, so you may be again asked for some other doubts. So now I would request Shri Pinaki Ghosh. He was in the NTPC. He was retired as GM. So he is going to just deliver on biomass co-firing, a strategy to combat air pollution and fuel security. So may I request Shri Pinaki Ghosh, sir, please be on the line, and over to you, sir.
साइकिल की क्या नॉर्मलाइजेशन ले क्या बायोमास में और जो
Pinaki Ghosh. मुश्किल স্যার আপনি জয়েন করুন হ্যাঁ 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 আপনি একবার বলুন আমি দেখছি Pinaki sir, are you online? Pinaki sir, are you there? Yes sir, now we can see you, but অসুবিধা কোথায় এই নিজেকেও আমি হ্যাঁ ঠিক আছে কিন্তু পিপিটি অন হচ্ছে না কই স্লোলি চলছে, আমি তো কিছু বলছি না এখন।
একটু স্লো চলছে, নেট হবে তো কিন্তু এই আপনি যে লাস্ট ছেড়েছেন এটা এখন
Pinaki sir, are you online? Pinaki sir, are you there? Yes sir, now we can see you, but এরকমই না, এবার রান্না স্টার্ট করেছে, ওনাকে আর টাচ করা ছেড়ে দিয়েছে কেন, ও নিজে এত ব্যস্ত। স্যার বলুন, আওয়াজ যাচ্ছে না, আপনাকে আমি দেখতে পাচ্ছি, পিপিটিটাকে শেয়ার করুন স্যার। বাট টিল নাও ইউ ওয়ার মিউট, এখন আপনি আপনি আনমিউট করে কথা বলুন স্যার। আপনি কিছু বলুন, তারপরে দেখছি। নো নো নো, but I am only able to hear you in the mobile, not in the. বলো, any suggestion?
ওনাকে unmute
হ্যাঁ করুন। Can we receive all the PPT that are presented over here? এরা দেবে আমাদেরকে? হ্যাঁ, আজকে জানা ম্যাডাম কোথায়?
আমার মেয়ের শরীর খারাপ, ফোন করেছিলাম।
মেয়ের শরীর খারাপ?
কোথায় গেলে, কোথাও তো বেরিয়ে গেল মনে হচ্ছে।
হ্যাঁ সুমিত বলুন। জয়েন করেনি, একটাই শুধু জয়েন করেছে, শুভেন্দু দে। হ্যাঁ, জয়েন করেনি। হ্যাঁ আজকেই
বলছি পিনাকি ঘোষ, আচ্ছা পেয়েছি ওনার সাউন্ড আসছে।
আচ্ছা আচ্ছা,
ঠিক আছে, পেয়েছি উনি
ঠিক আছে ঠিক আছে ঠিক আছে। আচ্ছা তা 2 তারিখে, হ্যাঁ 2 তারিখে, এটা 5 তারিখে এদেরকে নাহলে ওইটাতে পাঠিয়ে দিন না, টারবাইনে, তাহলে আর না ইয়েগুলো চেঞ্জ হবে না। দেখুন একটু যদি কিছু করা যায়। ঠিক আছে, স্ক্রিনটাও একদম ঝাপসা
শেয়ার করতে পারছি না, ওদিকে সমস্যা আছে।
কোনো সাইট অফিসে আছে, বাড়িতে নেই, আমাকে আবার ফোন করবে। তুমি একটু সাজেশন দাও না কিছু চেক করতে, কি করতে হবে। কি করতে হবে বলো।
আমার স্ক্রিনে এরকম আসছে, আমাকে এটা আনমিউট করতে হবে।
স্যার আপনার স্ক্রিনে আপনাকে আমরা দেখতে পাচ্ছি,
ভিডিওটা অন করা আছে কিন্তু সাউন্ড অন করা নেই।
আপনি স্যার আনমিউট করেছেন তো?
আপনার ওখানে ইয়েটা স্যার দেখাচ্ছে স্যার আপনার ওখানে যে মাইক্রোফোনটা ওটা ক্রস দেখাচ্ছে? হ্যাঁ সে তো নিশ্চয়, কিন্তু আপনার তো সাউন্ডটা পুরো মিউটই আসছে না। ক্রস না আপনার এন্ডে আপনাকে দেখা, আমাদের এন্ডে তো আমরা ক্রস করে রেখেছি, সেটা আপনার এন্ডে তো দেখি
দেখো তো।
না
না না,
এইবার আমরা মিউট করলাম আপনাকে, ধরুন আমি দেখি আনমিউট করে দেখি তো। এবার মিউট করলাম আপনাকে আমরা। মিউট, হ্যাঁ না এটা কিন্তু আওয়াজ আসছে না স্যার।
স্যার ওখানে কেউ আছে যদি একটু হেল্প নিন না আপনি, নালে মোবাইল থেকে জয়েন করতে পারবেন কি?
স্যার মোবাইল থেকে জয়েন করুন, মোবাইলে লিঙ্ক পাঠাচ্ছি।
স্যার স্লাইডটা ওখানে নিয়ে নিন, স্লাইডটা এখানে দেখান। স্যার আপনি না স্লাইড আপনার ল্যাপটপে দেখিয়ে আপনি মোবাইল থেকে কথা বলুন স্যার, হবে? তাহলে আগে স্লাইডটা শেয়ার করুন স্যার। স্যার স্লাইডটা শেয়ার করুন। অনলাইন সমস্যা বলে স্যার,
আর সেম লিঙ্কটা মোবাইলেও দিয়ে দিন।
মোবাইলে বোধহয় আমি দিলাম
স্লাইড দিয়ে
কিন্তু কেন হচ্ছে? হোয়াট ইজ দ্য টেকনিক্যালিটি?
মানে এখানে সাউন্ড আনমিউট নেই তো, এখানে সাউন্ড আনমিউট নেই তো,
মিউট হয়ে যেত না।
এইখানে সাউন্ড আনমিউট নেই তো, মিউট নেই তো সিস্টেমে।
Pinaki sir, are you able to hear me? Sir, you can try with your mobile also. I have shared the link on your mobile, on your phone also. শুনতে পাচ্ছে তো, করছে কোথায়?
দু জায়গায় লগ ইন করো, দু জায়গায় লগ ইন করো।
হ্যাঁ করে ভালো, একটা স্লাইড করবে,
একটা সিস্টেমে লগ ইন করো, একটা মোবাইল লগ ইন করে বলে যাও।
করছে তো, করলে আমরা এখানে বুঝতে পারবো তো। হ্যাঁ আচ্ছা আচ্ছা, এই যে পাত্তা স্যার।
হ্যালো
আবার ফোন করবো।
স্যার সিস্টেম সাউন্ডটাকে দেখুন, সিস্টেম সাউন্ড তো আনমিউট নেই তো, এই যে এই জায়গাটা। আর ইউ টকিং মাইক ইজ অফ। নাহলে দুটো লগ ইন করুন, মোবাইল থেকে লগ ইন যেমন আছে ওখান থেকে কথা বলতে থাকুন।
বলছি স্যার আপনার মোবাইলেও লিঙ্ক পাঠিয়েছি হোয়াটসঅ্যাপে, ওটা দিয়ে আপনি জয়েন করুন। হ্যাঁ সেম লিঙ্ক, সেম লিঙ্ক। ওকে ওকে ওকে,
এটা 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 চলতে দিন, এটা চলতে দিন।
আচ্ছা এখন আওয়াজ আসছে বোধে স্যার, একটা এসছে বোধে।
না না অন্য কেউ ফোন।
আচ্ছা আচ্ছা, এই সিস্টেমে অতটা কিছু থাকে না নাকি?
আমার মনে হচ্ছে এটা কিন্তু লেফট করে যাচ্ছে।
কি বলছে আবার? মোবাইল তো জয়েন করেছে, করছে না। ওকে মিউট করো। মোবাইলে দিয়েছে।
ঠিক আছে।
হ্যালো
কিন্তু ওদেরই তো permission জন্য নাকি? হ্যাঁ একটু দূরে স্যারকে কথা বলতে হবে না?
अभी आवाज आ रहा है ना?
স্যার একটা স্যার প্রেজেন্টেশনেরটা, স্যার প্রেজেন্টেশনের, স্যার মোবাইলটাকে ঠিক আছে, প্রেজেন্টেশনের সাউন্ডটাকে আনমিউট করে দিন। যেটা আপনার সিস্টেমে লগ ইন করেছেন সেটাকে সাউন্ডটাকে আনমিউট করুন। এবার বলুন, বলুন আস্তে আস্তে বলুন।
ओके
একটাকে আনমিউট করুন, সিস্টেমটাকে আনমিউট করুন, মোবাইলটাকে মিউট,
Sir, please mute the system sound
हाँ
and speak from your mobile, sir.
Okay, now the presentation is visible.
Yeah. Now presentation, sir, you speak, sir. I think now it is okay. You can start.
We can start. So I will be speaking only through mobile. My presentation will be through mobile now. Huh?
Okay.
Okay, next slide. Slide change. Change the slide. You can change the slide. Change the slide. Sharing हो रहा है ना?
हेलो हाँ वो আসছে তো अच्छा 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 ठीक है ठीक है ठीक है
ये पूरा शटडाउन कर दिया
স্যার
হ্যাঁ
আপনার প্রেজেন্টেশন তো অফ হয়ে গেল
No, presentation actually 1 minute. 1 minute. Again I am switching it on.
Okay.
Just a minute.
Okay.
I thought I'll be sharing through phone only. Google Meet में तो नहीं था नहीं वो प्रेजेंटेशन खोलना पड़ेगा combination होते हेलो इको हो रहा है ना यार, इको हो रहा है ना। हेलो हेलो
Yes, sir. Hello.
now the sound is coming, madam.
Yes, sir. Now it is okay, sir.
Now it is okay. So now these slides are also
Yes, yes.
visible.
Slide is also visible, sir.
Okay. Thank you, everyone. It's really a very awkward position for me also, and I made several presentations, and this is the first time I am facing this type of problem.
No issues.
Anyway, it's a learning for me. To start with, it is a learning for me. And so through mobile, my voice will be through mobile,
Yes, sir.
and the presentation will be through my desktop.
Yes, sir.
Let me introduce myself. My name is Pinaki Ghosh. I retired from NTPC in 2019. And when I was there in NTPC, NTPC have given me the opportunity in several power stations, and almost 8 to 9 power stations I worked. And when I retired from corporate center. And when I was retiring, that time actually, my previous speaker, Mr. Govar, actually he has answered all the questions which I was thinking to cover through my presentation. So he made my job much easy. I got the telephone call from yesterday only from NPTI, though they have informed me earlier, but the timing of my presentation was not very much confirmed. So I am here now at NSPCL Rourkela, for a condenser chemical cleaning. So I am caught in between. So I beg your pardon so that I can finish my presentation as quickly as possible, and it will be done also because Grover has mostly all the points he has covered, and all of you are from operation background, so all of you have quite like rather you are more experienced than what experience I am having. But as being a chemistry person, when I was there, that co-firing basically started from 2017, the order from the Ministry of Power Secretary, and then 2019 we had a conference at our this PMI Power Management Institute, where there was I was there in that conference. So that was the beginning, and that NTPC thought that to move forward in a big way, and accordingly in Dadri that experimentation was carried out, and Grover has experienced very nicely. I have also learned a lot of things. Now during that conference also, and subsequently also, what I learned that quality of the product is very much important. So though my presentation was in the line of what Grover, my previous colleague, has presented, since it will be sort of repetition sort of type, so I will slightly change my presentation more towards the sampling and analysis part, because this product, like imported coal, not like Indian coal. Indian coal sampling and analysis basically done at the loading end. So based on the loading end quality parameters, the payment is made to the coal company, to the supplier. But in this case, like imported coal, based on the sampling and analysis at the receiving end, the payment is to be made. So just like imported coal, here the commercial part is very important, and the responsibility of the chemistry department becomes more. So how the analysis is done, it is just like imported coal. Exactly, those who are, maybe some of you may be associated with imported coal sampling and analysis. So it is the application of the same thing. Only thing is the parameters and specs are different. All the this subsequently after this 2019 conference, the size specification have been made for the pellets and the codified plates, everything have been made. So all these size specifications also are there with me. If any of one of you wants to know about the IS specification, I can share it. So that is what is the background of the presentation. And I'll request, since already it has to be started to be from 12:15, and half hour time was given to me. So accordingly, I made my time slot adjusted over here. But that all of you are from this operation Bangkok, mostly as I understand by going through the previous presentation for 10 or 15 minutes. That's condenser chemical clean, though it is not your topics today, but there is a problem because the chemical is going to the from water side to the steel side, so I have to rush over there. So accordingly, I have to finish my presentation very, very quickly. So please pardon me so that I can finish it at the earliest. So I'll go through the presentation, which I was thinking to present this here, but after going through the previous presentation, I understand that most of the things have been covered there. So I'll quickly switch over to the sampling and analysis part. I mean the specification part. Is it okay? This much, whatever I said, to sum up, is it okay? I mean, why am I asking, since I am communicating through, my voice is through mobile. So let me know whether my voice and whatever I wanted to communicate, is it clear now? So I can proceed then.
Yes, sir. Everything
Yes,
is
anyone
clear.
can respond? Yes. Everything is clear. Okay, fine. So let me go through very quickly. So all of us know that global warming or the impact of pollution and danger, greenhouse gas, particulate matter, and toxicity, the burning of coals, and the effect of that on the lungs, on the upper respiratory part, and how to prevent it. These are the general things all of us know, and these are the some of the data. This presentation, when I was there in Simedri, we had a professional circle. So in that professional circle, we made it, but subsequently I transferred. So personally, if you ask me how much experience I have on working with this biomass firing, so I don't have direct experience, but the initiation of planning and everything, how to go ahead, how to do the sampling, how to create the infrastructure and logistics, I was associated with that. And then I transferred to some other projects. So when I got a telephone call from Madam, I thought, let me learn as well as share my the thoughts also through this presentation. So these are the some of the data through newspaper that in India, due to this particulate matter pollution, the death levels are much higher compared to other leading cities and developed cities in the world. And we can quickly go through, and this the air quality index everywhere. If you go to the big cities, what is the AQI level, it is displayed, and these values are very high. And since cities, the presentation is centered for the northern India, so values will be here given on the accordingly. So this is the thing. 1 ton of, if you the stubble is burned, if this slide is somebody is already presented, I do not know. So the amount of sulfur dioxide emitted will be 2 kg, particulate matter will be 3 kg, and NEO will be 60 kg of carbon dioxide. Just एक बार इनके को फोन करो ना, इस टेलीफोनिक इनके उधर फोन करो. And your 60 kg carbon monoxide, 1.4 ton will be carbon dioxide, and 199 kg will be ash. And impact, I need not to explain what are the impacts on the atmosphere, the haziness, and the that problem of the upper respiratory part. And the impact is another impact that the while if it's burned on the soil overall soil quality deteriorates because it kills the microorganisms, it raises the temperature of the soil, and overall it raises the temperature. So it's a burning of fossil fuel was it was banned rather. Now these things also that India generates about 511 million tons of agro residue per annum. and out of this 145 million ton is the surplus. Other one is either recycled or used, and through this we can generate about 30.
Sir, sound is not coming.
You are not audible, sir.
Sir, you are not audible.
উনি কথা বলছিলেন হঠাৎ মিউট হয়ে গেছেন। ও লেফট দ্য মিটিং। ফোন আচ্ছা ওনার নিজের ফোনে হচ্ছে না তো, তাহলে ফোন করবো?
উনি নিজের ফোন থেকে কথা বলছেন এই তো?
না বলছি করা যায় তো।
চলে এসছে।
কোথায় চলে এসছে? উনি এই ফোন থেকে কথা বলছেন, রাঘবেন্দ্র থেকে ডিসপ্লে করছেন, নিজের ফোন দিয়ে কথা বলছেন না, রাঘবেন্দ্র থেকে কথা বলছেন, নিজের ল্যাপটপে ডিসপ্লে করছে বলে
কি নাকি ঘোষ, এটাকে
ফোনে কথা বলছে বলে। কেন
আরো ফোন এসছে না, ফোনটা রিসিভ করেছে, ভয়েস মিউট হয়ে গেছে।
Hello. I think he's got some phone call, so he is speaking maybe.
অনেক ভয়েসটা একটা করলে একটা মিউট হয়ে যাবে, দুটো একসঙ্গে চলবে না।
পিপিটি স্লাইডগুলো চলে যাচ্ছে।
টাইমার দেওয়া আছে না?
আমরা এটাকে আনমিউট করতে পারবো না।
আচ্ছা মিউট আমরা আনমিউটও করতে পারবো, কিন্তু আপনার মোবাইলে দুটো একসঙ্গে ভয়েস যাবে না, একটাকে মিউট করে দেবে। ওই যে ফোনে কথা বলছি,
কটা স্লাইডস আছে সেটাও বোঝা যাচ্ছে না। কি হলো? হ্যাঁ আবার আনমিউট।
Hello.
Yes, sir.
I think I was disconnected.
Yes, sir. Now it is okay.
Okay, so I don't know why I got disconnected.
Yeah, now it is okay, sir.
Okay, but where did I left? I do not know because I was speaking so fast, so I did not see when I got disconnected. So what I was telling, it is carbon neutral because this biomass fuel, it contains more hydrogen than carbon. So since it is contains more hydrogen, it emits less carbon, it emits less carbon dioxide. So that is why it is carbon neutral. That means the amount of carbon dioxide, it is same amount of carbon dioxide it is getting sequestered by the plant. So that is why it is called carbon neutral. So I think after that it got disconnected. And this is the amount of this residual biomass available. With that we can generate around 30,000 megawatt. And these are the state where the potentials are very high. And this is how the flow chart, you take the feedstock, if it is wet, you go for drying, then grinding, then go for buffer storage, then pelletization, then pure packing and storage. If it is not if it is dry material, then we can either it needs to be grinded, or it can be straightly, if the size permits, we can straight go for buffer storage and pelletization. So this is the flow diagram for pellet production. And torrefication, I need not to tell, all of your sufficient talk has been done. Torrefication is nothing but pyrolysis to be done at 200 degrees centigrade, where that some chemical transformation will take place in the fuel, so that fuel becomes more efficient. So this is how the benefit of purification. And this thing already I have told, I think. This is the plan of action. These things are also I am skipping it. Now, as I was told, this is the part I will try to quickly cover. Let me, because sampling and analysis, as I said, is a very important part. So when I was there in NTPC Simadri, Dadri was the first plant in NTP, in India, where the first trial was taken. So with that experience, subsequently in other stations of NTPC, it was to be, it was further. I think now most of the power stations are now co-firing. But initially, when we started with this. In this formation of this, I was there. Then I left. So finalization, that is it's like a flue gas deceleration. Lot of logistics and other things are to be made. So finalization of truck movement, finalization of weighment point, arrangement of cabin of computer, earmarking of area for unloading, then arrangement of facility for unloading of trucks, stacking, contract, pallet how to feed, procurement, so modification of milling system, as Grover has told already. So all these things with the feedback of Dadri experience, this experience, from this experience at NTPC Simadri, we made our own roadmap on this. So on this roadmap, now the regularly also, Simadri also this co-firing is regularly going on. And as I told you, the next part is your specification. Just a minute. So specification part I will cover and I can. This is where I worked this station for 16 years. So this part we made it. As I told you, since the sampling and analysis is payment, the commercial part is also very important, though it is 10%. So commercial part is also important. So we made the payment on the basis of sampling and analysis at your unloading site. So the sampling and analysis report has to be unbiased. It has to be representative sample. It has to be accepted by the seller, and there should not be any confusion that there has been some biasness either this side. So that is why the sampling is along with the supplier, the sampling and analysis part was decided jointly and agreed upon. So just exactly like your simple sample, the 10 to 15 kg of sample is to be collected and mixed thoroughly and reduced to 3 to 4 kg by using cooling and quarterning and divided into, so the sample 10 to 15 kg sample would be divided into 3 parts, part A, part B and part C, jointly by in presence of NTPC and the supplier. So GM it is written means it is NTPC, so don't go by that. So now approximately 1 kg of the sample will be taken. So many of you may not be knowing that first test will be done to ensure that the consignment will be actually accepted or totally rejected. So you cannot wait the all the analysis will be 10, then you say that okay, this part is rejected, because you can hold the consignment. So what we did, immediate analysis is done by moisture method. As far as 1350 per 2, anybody want I can share. So if the moisture is less than 14%, if it is yes, then it is accepted. Yes, please, anybody wants to share on anything? Yes? Is it okay? Madam, is it okay or anybody can answer?
No, it is okay, sir. It is okay. You can proceed.
Okay, I can proceed. So if it is the moisture is less than 14%, it is accepted. If it is not, it is totally rejected. So you know that the analysis of moisture by this moisture balance method, it doesn't take much time. So that much you have to hold the consignment on the truck. Then if the particle size, then I do the particle size by sieving. It is not a very time consuming, as Grover has told. And if the particle size has to be 1 to 3 mm, 100% through sieving through 3 mm size and 1 mm 75%. If this meet this specification, then you accept it or reject it. So these two analyses are the initial acceptance and rejection of the consignment. So means the just like imported coal, but imported coal is slightly different. Imported coal, what we do? Imported coal, we do the sampling and analysis for 3-4 days, and then we do the price adjustment. But here it is not like that. Either you first accept or reject. Then if the parameters are deviating within some accepting or rejecting range, then you do some price adjustment. So this is the difference between imported coal and this coal. Okay, then suppose this is accepted. Now if it is accepted, now the part B and part C will be analyzed. Part B will be analyzed for fineness and diameter. Part C will be analyzed for GCB. GCB as usual for 200 micron. I am not going into detail on that. And that GCB part is, this part is done jointly, the fineness and the diameter part. And the GCB part is divided into, this is the most important part. Your price adjustment is based on that. So part 2, part 1, part 2 and part 3, 3 parts. One is referee, one is supplier will be taken, one will be sampling analysis will be done at our end. And then finally the price adjustment will be done. Okay, so this is the this part. Now other parts all of you operation persons may be knowing, but this is exclusively our chemistry part all of you may not be knowing. So I thought to share this part, then again I will go back to my main presentation and I will finish it, because as I said you I have to move to the site again. So this is the biomass specification. 1 minute. This is the biomass specification, though Grover has already told, again I am telling. So this is what the diameter, how much diameter, 25, if it is not 35 mm, it is 35, and your fineness should not be less than 5%, and your 25 GCB is 4500, if it is not 25, it is to be mentioned by the bidder, or during our LOA we have to mention it should not be less than this much. And moisture, as I told, fineness also I have told. So rejection criteria I also told that if the moisture is more than 14%, it will be rejected. And GCB less than 2800, then it will be rejected. So these are the, and 25 were this much. These are the criteria was, and these are the specifications, and these are the sampling flow diagram we have prepared. And these things I am skipping, and the benefits I will come. Directly to the benefits and close. Benefits. Now cost of coal is your 4,000. See, this is also Dadri study. Cost of coal, this thing Grover has not presented. Cost of coal is 4,650 per metric ton. Cost of biomass pellet is 6,000, slightly costly, 6,000 per metric ton. Cost of coal for fuel or full load operation, this was calculated for 3 units. Cost of, if you fire it biomass, cost of slightly rise up or cost will be there, so there will be price rise of only 4.55 cents. So if you go for biomass, as such there is cost level, cost rise is very, very marginal. 4.5 paisa only per unit. And the main benefit is that your reduction of okay, one thing is that whether do you get any impact or efficiency or not. If you go for higher, because since it is having if it is having moisture, it will impact the efficiency. If it is the moisture is less, it will not having any, as I understand, there will be no impact on efficiency, as I understand from my persons who are already on the operation and the efficiency side. So the optimum, I think optimum firing should be, if you firing less, I mean 10% to 15% firing is optimal. Now if you the benefit of emission is that your specific coal consumption with 15% core firing will be, say, your 954 kg per kilowatt hour, and if you do not co-fire, it will be more than 1 kg per kilowatt hour. So there is the big direct benefit of your your emission. So that is why it is recent for every 1% increase in co-firing, there is approximately 1 to 1.3% drop in GWP, means global warming potential. So co-firing biomass at 15% biomass that reduces the global warming potential by 18%. right? So this is the data, and this is the how the specific CO2 emission will be reduced if you co-fire with biomass firing. Around 1 generally the specific coal consumption, but if you co-fire it is almost going to touch point to it. So huge there will be your gain in GHG emission. This is another slide how the your CO2 emission per ton is reduced. I am quickly skipping through this slide. Now, other benefits are that it creates a lot of employment, source of income to the farmers. Right? These are the things we have prepared there. I am skipping this. So this is the conclusion. I am quickly finishing it. I may be pardoned because I have a lot of things I thought I'll be sharing because of time, and most things that I have to go to site because I am already there at site, and there is some problem. I am repeatedly getting the telephone call. So, madam and my dear, my esteemed participants, please excuse me. And to conclude my presentation with this slide, and it improves air quality index. Based out of waste renewable energy gives fuel security, net energy balance improves compared to mining and transportation, income to farmers, socio-economic developments, and our sustainability towards vision and mission of not only NTPC to all our power sectors. So with this, I want to close my presentation, and if any question, anyone you can ask, because I thought a lot of things I will share. I had lot of presenters I had with me. Specifically on the sampling and analysis part, I thought I will be covering because Board mostly it has covered on the operational part. So if any question is there, quickly 2 and 3 questions I can answer, or otherwise I can take leave. So my esteemed participants, please, and madam, you can also.
So if any questions from the participants, we can take 1 or 2 questions. Otherwise, we can break for lunch. Sir, assuming that now we can proceed with for the lunch. If any questions are there, we can take it because sir will be available on mail, and we can definitely pass on for that. And now we are going beyond. Yes.
Yes, please.
Sir, please describe the qualified and non-qualified. I'm just missing this.
Okay, torrefied. Torrefied means pyrolysis. You know what is pyrolysis of coal? It is basically pyrolysis of the, during pyrolysis, if you raise the temperature to, not to the temperature where it will burn. You raise the temperature to a certain level, say 200 degrees centigrade, what will happen? So there will be some quality changes on the fuel. During that quality changes, you will get your GCV will be improved. Okay, your GCV value will be improved. So that is what is called pyrolysis. So pyrolysis of coal and pyrolysis of fuel, if you can search your GCV, Google, you will find it. So during pyrolysis, what happens? Your GCV improves. So here your pellets, you can ask any stations. I think the GCV is between 2,600 to 3,000 like that they may be getting. But if you get this torrefied plates, I think nowhere in NTPC now torrefied plates are being used. If you use torrefied plates, your GCV will be raised to as high as 4,000. The cost will be slightly high, but your GCV, your improved GCV will be much more compensated if you use the cost of pellets will be compensated if you use the torrefied plates. That I am sure.
Sir, actually we have a ball and recipe, and I saw that just here only qualified can be used. So what is the reason behind that? Where? Actually, we have ball and recipe.
Okay.
Ball and recipe, where we can use only qualified. Why? My question is why?
Maybe I have to think about to answer your question more clearly. But I quickly I can answer is that the torrefied plates one is it's actually your moisture volume and everything almost 14%, 15% remains at that level. Only thing is that it improves the GCV level. So since it improves the GCB level, I don't know the design of your fuel and other things. Maybe in according to that, you maybe this to decide to use the 25 plates only.
Sir, only, sir, just tell me that in our Holland is we can use the non-25 version.
Give me some time to answer your question. You can share your mail ID or phone number, madam, with me. You can just share with me. Just WhatsApp can also we do. What is your type of your boiler, and then I will try to answer it. Because why it is only asked to, because generally if it is biomass can be fired other than GCB, there is no difference. I don't find any difference as far as the quality I have seen. So why it is specifically still insisting that only 25 pellets should be used? I may not be able to answer your question fully at this time, but it must be related to GCB. That much I am sure.
Okay,
Yes,
thank
any
you.
other question? Thank you. Any other question, please?
Sir, I think it's already 1:30.
Okay, then let me conclude.
Sir,
This sampling and analysis.
Pinaki sir, I would request you to be online today after your work is over, so that if there are any questions, the participants will add in the chat box. So if the questions I will just communicate to you, you can give the answers.
Right.
And
Right.
end of the program after 4 o'clock, there will be a question answer session, sir. I will invite you. So if any questions related to your topic, you can answer, sir.
Okay, because since I have passed this move through my presentation very fast.
Okay, sir. Okay.
And that sampling and analysis part is a very important part. Before in conclusion, I will tell, and there are a lot of specifications have been made. So we have to go by that specification analysis. But that part you may not be, all of you may not be knowing, but a lot of things are there in that part also.
But still, sir, I would appreciate, sir, that you have given your time in spite of being in the site and going on for some consultancy work and also. Thank you so much, sir. And we always look forward to your association with us. Now, I would just announce that we will break for lunch. It is 1:30 now. And as per the schedule, we were supposed to start at 2 o'clock, but I think we need some more time. So should we start at 2:30? Is it okay?
Okay.
So if Kakar sir is on the line, I would request him, sir, kindly if we can reschedule and start from 2:30 if you have no problem.
Okay, madam, I am taking leave.
Okay, sir. Thank you. Thank you, sir.
Thank you. It will be okay.
2:30 is okay?
2:45, ma'am.
No, sorry. It is a one-day program. We do not have so much time. But I would announce that we start the next session of Sri Subhash Surendranath Kakar. He will be presenting on the economies and risk management after using biomass pellets, challenges and mitigation measures, and some case studies too. So request all the participants to be online. Come back after lunch at 2:30. Have a nice lunch. Thank you.
चल खाओ टाइम कम में खाओ बाबा पढ़े नहीं खाए
आजकल बाबा 1 बजे के पहले
हाँ बाबा अपना टाइम में वो पंडित जी के स्टाइल में चल रहा है 1 बजे हाँ
पंडित जी को क्यों माफ
ना वो पंडित जी जैसे 1 बजे
एक आदमी के बारे में बोला उसको भी खींच ली भाई
पंडित जी 1 बजे खाते हैं भाई साहब जो टाइम मिलते हैं वो तो रिलीज ऑर्डर बाकी तो मैडम
I request all the participants to please join through the link and be ready for the next presentation which our Surendra sir will be presenting. So Kakkar sir, I hope you have joined. Am I audible? Surendra sir, have you joined? Fine. Kakat sir, have you joined? Good afternoon, everybody.
Good afternoon, ma'am.
We'll be starting the next session after lunch. So, Kakat sir, have you joined?
Good afternoon, ma'am.
Good afternoon.
K. शुरू करना है नहीं तो কাম হবে না ওরে ওর ট্রেনার কেন বলছে যে ফ্রেন্ডলি নয় ও ট্রেনার বললো ফ্রেন্ডলি নয় জিজ্ঞেস করে নিলাম আগে না না কুকুরটাও
I would request the participants to please be on mute. Request the participants, please be on mute, sir. Sir, Kakkar sir, have you joined, sir? Good afternoon, sir. Have you joined, sir? Kakkar sir?
Yes, madam, I've joined.
Okay, sir. Okay. Sir, you're sharing your presentation, sir.
Madam, the presentation is visible now?
Yes, sir. Yes, sir. It is visible.
Okay.
Sir, are you speaking? Because we are not able to hear anything.
Ma'am, I thought you will let me know when I have to start. Okay, I'll start.
Yeah. Sir, we are ready, sir. We are having with us Subhash, sir, an AGM from NPPC Dadri, sir, and quite an interesting topic on the economies, the risk management, and the mitigation measures. Sir, we are eager to hear from you, sir.
Okay, thank you, Indra. So, a very good afternoon to all the colleagues. We have a session on biomass pellets, economics and risks. Sir, this is a case study of NTPC Dadri project. This is the agenda that I am likely to cover in this topic. So, from the very beginning, NTPC is a socially and environmentally responsible organization. It has its own environment policy, which it formed in 1995 to take care of the environment within and outside NTPC. It's its first organization to do this, and presently NTPC Environment Policy 2021 is in force. NTPC has separate funds for environment management to take care of environmental issues in and around NTPC stations. It shows the concern of NTPC towards green and sustainable power generation. NTPC has commissioned a capacity of 1,365 megawatt of RE projects under its own capacity addition. 2,029 megawatt of RE projects are under implementation, out of which approximately 200 megawatt constitutes floating solar. This is a photograph of NTPC's biggest floating solar, Simadri floating solar. To take care of conservation of natural resources, NTPC equally focuses for exploring of alternate fuels like biomass pellets, torrefied pellets, etc. Stubble or parali is a method of removing crop residues from the field to sow the next crop from the last week of September to November. Stubble burning is a process of setting on fire the straw stubble left after harvesting of grains like paddy, wheat, etc. In October, rice is harvested and rabi crops must be planted within a few days after removing the crop stubble. So the easiest way out is the farmers set the stubble on fire, and this leads to a lot of smog and a lot of pollution. In earlier days, only a small portion of the stubble was burned. However, of late, due to labor shortages and increased use of harvester for harvesting the crop, we have more stubble, and this leads to a significant rise in the crop residue burning. In India, rice, wheat and sugarcane contribute to almost 80% of the agro residue. So this slide shows you the gross residue is 560 million tons, out of which surplus residue is 260 million tons. If this 260 million tons could be diverted to the power plants, then this much amount of parali burning would be saved. Because of parali burning, the air quality, mainly in Delhi NCR, deteriorates, and NTPC has explored the use of biomass as an alternate fuel at Dadri. They started the first trial of co-firing in 2017 with a target of 100 metric ton biomass firing. We needed to make changes in our boilers. It was not a smooth ride. We had to make system modifications so that we could fire the parali with the existing boilers. Blending of biomass pellet was done in various ratios to evaluate its impact on the existing system. After successful trial of biomass pellet, it was implemented since November 2019. About 750 million tons of biomass is produced annually in India, out of which 280 metric tons is surplus, 280 million tons. and half the agro waste is used as animal fodder and energy source in the rural India. NTPC also raised awareness to avoid stubble burning. Biomass co-firing has shown reduced emissions because in case the biomass is not burnt as stubble, it will be under controlled combustion conditions in the boiler. If it is burnt, then the emissions are reduced. This is the photograph of biomass pellets being fed through coal conveyor to NTPC Dadri systems. This is a photograph of the mixed coal and biomass pellets being fed to the mill bunkers. Now coming to the economics and the risk management part. Sir, if you have any questions, we can discuss at the end. Coming to the economic part, techno-economic evaluation of the electricity generation through pellets. Sir, please put off your mic, otherwise you will not be able to hear what I am speaking. The current market price of biomass pellets is 5 to 6 rupees plus transportation. Earlier, these pellets were used mainly for cooking applications. To ensure the commercial use of biomass pellets based power project, the biomass pellet unit should be installed near the project. As you have seen, almost approximately 50% of the cost of biomass pellets is the transportation cost. So, the CRC specified the biomass fuel price during 2012-13 as per indexation mechanism. This is the fuel price as specified by CRC for 2015-16. Basic prices of biomass pellets are almost common, but the transport distance is the decisive factor. The biomass producing agency from the plant, the cost will increase on account of increased transportation. So states need to assess their respective potential for the agriculture and forestry residues, determine the targets and ambitions for biomass based electricity generation and devise strategies. So once NTPC realized that the transportation cost was significant, so we split the pricing into two parts, the basic biomass price and the transportation price separately. We floated tenders, and as we discussed that the supplier has to be from nearby area, so our condition was that the supplier should be from the nearby states like Punjab, Haryana and UP, so that the transportation could be kept lower, and hence our target was to keep a transportation cost of less than rupees 2,000 per metric ton. Accordingly, NTPC finalized 3 agencies and awarded a contract of supply of 280 metric ton of biomass pellets for 4 years. 280 metric ton was based on basically the requirement of not full load, but since NTPC Dadri was having reserve shutdown very frequently, so this was a very optimistic figure assumed. But of course, of late, from March onwards, with stage 1 having power purchase agreement, now instead of Delhi, it has been shifted to Rajasthan and Gujarat. So the power plant is running at almost 76 to 80% PLF. The levelized cost of electricity is estimated as the ratio of total cost, annualized cost of biomass to the annual cost of electricity produced. So let's talk about the investment and in the system modification. Since, as per design, NTPC Dadri was designed to fire 100% coal or oil. So to use biomass pellets as a co-fuel, the system needed to be modified. So we had to modify, we had to install a truck tippler, we had to construct a shed for temporary storage of the biomass, we had to install a moving scale for biomass measurements. The biggest challenge was to avoid ball mills fire during the milling of the biomass. So that was carried out, and Dadri invested approximately 2 crores on account of the various modifications to use biomass pellets for power generation. Now, we invested some amount. How do we recover whatever the cost we are incurring? So how much is the impact on the energy charge rate? Energy charge rate increased by only about 9 to 12 paisa per kilowatt hour power generation, with about 90 to 95% coal firing and 5 to 10% biomass pellet firing. The cost slightly varies as per GCV of the biomass pellets. With the lower GCV, the ECR will slightly increase, and with the higher GCV, the ECR will slightly reduce. The major risk of biomass pellets is the availability of biomass pellets throughout the year. As we have seen that immediately after crop harvesting, biomass pellets are available in plenty. Thereafter, the availability of biomass starts tapering off, and after some time, they are not available anymore. So, we have dedicatedly allocated 2 mills of each boiler of each of the units for biomass firing. One of the constraints is biomass pellet is to be used as soon as it reaches the site, and it cannot be stored due to its very inherent nature. It is hygrostatic.
Sir, you are muted, sir.
Sir, you are not audible.
Subhash, sir, you are muted.
Okay.
Now you are audible, sir.
Sir, biomass pellets is to be used as soon as it reaches the site, and the biggest issue is it is hygroscopic. So if we store, it absorbs the moisture, and if the moisture goes above 15%, then it becomes very difficult to mill the same in the mills. So then it becomes not usable in the power plant. So what are the challenges and how we manage to meet the challenges? In this table, you can see the challenges, what were the mitigation measures, and what was the result. So the initial challenge was maintaining the supply chain. We had vendor development, multiple sources of supply were ensured, and ultimately it resulted in a regular supply achieved. However, as I said earlier, that as soon as harvesting takes place, the biomass pellets will be available, but after some time, the supply tapers off. Quality of biomass pellet was getting deteriorated. For this, we have ensured that the transportation is through covered trucks, and this maintains the quality of biomass pellet. Only on reaching Dadri site are we removing the covering of the pellets or taking off sample, etc., so that moisture pickup is reduced to the very minimum. Safe unloading of the biomass pellet was ensured by development of truck tippler, and this ensured that the safe unloading was there. We needed to integrate the handling of and co-firing with the existing system available. So we made various modifications in the existing system, and a stable firing was carried out in the required blending ratio. The biggest challenge was fire possibilities during pulverizing because of the chemical composition itself. The modulation control of hot air damper and cold air damper was provided at the mill inlet rather than the mill outlet. For conventional firing, we were having it at the mill outlet. However, for biomass, we shifted to mill inlet. So this way we reduce the fire possibilities. So we have to ensure uninterrupted supply. For this, we have developed the vendors. We have to control the fugitive dust emission during unloading. For this, a covered shed has been provided for unloading and temporary storage. Let's discuss the best practices. We have ensured moisture-free environment for biomass pellet. Blending ratio, we are using from 5 to 10% only. Adherence to the biomass pellet specification. The existing system was suitably modified for co-firing of the biomass pellet. The biomass pellet firing was integrated with the existing system of coal firing. System was automated for unloading and feeding. And we are maintaining mill inlet temperature to avoid fire during pulverization. What were the learnings from this biomass pellet firing? That moisture-free environment to be ensured, modulation control provided for mill inlet, biomass pellet firing to be restricted to less than 10%, proper grinding of biomass pellet to be ensured to reduce the unburnt carbon, and biomass pellet ash has high resistivity. So just because we are firing very less amount, so it does not give any significant impact on the ESP performance. But in case the quantity...
Sir, I have a question.
Yes, sir.
Sir, modulation control. What do you mean by modulation control in mill inlet point?
Sir, modulation control, I already talked about the control of hot air damper and the cold air damper. That is what is meant by modulation control.
Okay.
Sir, what are the benefits? The tangible benefits are to the industry. It is conservation of natural resources. Greenhouse gas reduction. Biomass has less of ash. Reduction in O&M cost for SOx emission control devices. Energy recovery from waste. And benefit to the farmer is it enhances the income of the farmers. So basically, biomass firing is a win-win situation both to the industry and to the farmer. What are the opportunities on account of biomass firing? The large-scale use of biomass will create many opportunities in the sector for collection, transportation and processing of biomass. It is estimated that a truck of 6 tons carrying capacity would be used 3 times in a day to transport the raw material within 50-kilometer radius, and to maintain the feedstock requirement, 2 trucks are needed, and with 2 persons, a driver and a loader assigned to each truck. So these estimates indicate that 2,24,000 full-time employments would be generated if we are able to use the complete 280 million tons in biomass pelletization and in the transportation of agriculture and forestry residues. Biomass co-firing will account for integrating renewable energy in the coal-based power plants. It will also lead to becoming carbon neutral with the proper harvesting, processing, and transportation management. Now, with solar and wind, we have a requirement that during the daytime solar is available, but as soon as it becomes dark, we require the backup of conventional capacity. However, in case of biomass, it does not require a backup since we are firing along with the conventional capacity. So, it helps schedule as per load demand and eliminates the indirect cost due to variability of solar and wind-based renewables. So, biomass firing is integrated within the conventional capacity installation itself. Now we talked about the economics of the biomass. So what Government of India did for making changes in the policy, looking at all these benefits, Government of India revised the policy to use biomass pellets in coal burning thermal power plants. The decision was announced on 9th October 2021 and it made it mandatory that all thermal plants to use 5% blend of biomass pellets along with coal. This policy comes into force from October 22 and it is required that the biomass firing should be increased from 5% to 7% within 2 years for two categories of the power plants. The policy for co-firing will be in force for 25 years or until the end of the useful life of the thermal power plant. Sir, coming to policy related to tariff and scheduling, for certain projects which are set up under section 62, that is, which are set up under regulations made by the CERC, the increase in cost to the power station due to co-firing of biomass pellets shall be passed through in the energy charge rate itself. For projects set up under section 63, that is, which are standalone system and which are under Electricity Act 2003, the increase in cost due to co-firing will be claimed under change in law provisions. We also have apprehensions that additional PCR will lead to change in the merit order. However, it is clarified that the impact on ECR on account of biomass firing shall not be considered in deciding the merit order dispatch of the power plant. One more, that DISCOMs have certain renewable purchase obligations. So, all the DISCOMs that have renewable purchase obligations, by purchasing power from biomass firing, these obligations can also be met by the DISCOMs. Some of the news coverage for the last year, 58,000 metric tons of biomass was fired in the country. Approximately 12 million metric ton tenders were in the process. In NCR itself, biomass co-fired stood at 21,000 metric ton up to March, and tenders floated in the region were about 5.50 million metric tons. The biomass firing is also being monitored by CAQM, Commission for Air Quality Monitoring. So, we have received a letter from CAQM on 22nd of June, wherein they have again given us information that as per direction number 42 dated September 21, government has directed that 5 to 10% co-firing is to be done for all power plants within 300 kilometer radius of Delhi, and with focus on maximizing the quantity of paddy straw. So the biomass firing is important. It is being monitored by CAQM. Some of you might not be knowing, due to the high pollution levels in NCR region and in the vicinity of almost 300 kilometers of Delhi, there is a provision called GRAP, Graded Response Action Plan. That is, when the pollution levels touch a certain level, certain remedial measures get triggered. So it's a graded response depending upon the level of pollution. As the level of pollution increases, more and more measures need to be taken to mitigate the same. So last year, under the GRAP, CAQM directed that out of 11 power stations in NCR region, only 5 were allowed to operate and 6 of them were shut down for the period during Deepavali. That was almost for about 45 days. So this is the level of seriousness by the government, by CAQM. Some more news coverage was that some public and private companies have started co-firing. Results are encouraging, and we can safely go for 5 to 10% co-firing in all the plants. Ministry has said that as per Ministry notification October 21, it has been made mandatory for all the power plants to use 5 to 10% biomass. In conclusion, I would like to say that in India, there is a clear recognition of the significant role of bioenergy in electricity generation. Bioenergy can be used in 2 different forms, pelletized and non-pelletized. The non-pelletized forms have been used in co-firing in thermal power plants. Biomass pellets are being used extensively and international trade is increasing year on year. After allocating biomass feedstock, it is estimated that the net residue availability for biomass pellet production will gradually increase, and the pelletized biomass has potential for approximately 6% of India's total electricity requirement. Cost of biomass electricity will ultimately determine whether the technical potential will be utilized or not. Carbon price can play an important role in increasing the penetration of biomass pellets. For states with lower tariff for biomass power, the break-even price is estimated at 1,600 rupees per ton of CO2. Sir, Dadri has been not only using the biomass pellets, but it was also sent some MSW waste, which was in codified form through Delhi Jal Board, and that almost 15 tons of codified waste of Delhi Jal Board was also consumed in co-firing at NTPC Dadri. Thank you. If you have any questions, you can please ask.
Sir, I have a question.
Yes, sir, please.
Sir, what kind of biomass pellets are you using at Dadri? Codified or non-codified?
Sir, we are using non-tarified biomass pellets.
And what is the average GCV of those pellets?
Average GCV is almost near to coal.
Okay. And sir, apart from building a shed, have you taken any other measure to counter the moisture problem during storage?
Sir, since the quantity was very less, so presently we only have a shed. And as I already discussed, that we make it a point not to store. So what is happening is, as soon as we get the pellets in the morning, so our chemistry department takes a sample, and as soon as the chemistry department gives us a result that the moisture is within limits, we immediately unload it and we take it to the mills so that firing of the same can be done. So on the same day, firing takes place. So we don't store the pellets so that moisture pickup can be there.
Thank you.
Any other questions, sir?
Biomass file.
Sir, I have a question.
Yes, please.
Using biomass clay, is there any additional system required in PF fired boiler?
I couldn't get your question, sir. Please repeat.
Is there any additional system required for PF fired boiler for using biomass fleet?
Sir, we have a pulverized fuel firing only. The only thing is we had to make certain modifications. I think my earlier colleague, Mr. Rohit Grover, must have shared all the details. But the main issue is, since the biomass has more volatile matter, so there is a risk of mill fire. So basically that was one of the main issues. That is why, as I already discussed and my colleague must have also discussed, that the mill temperature control was shifted to mill inlet temperatures. And certain CNI modifications also need to be done.
Okay.
Any other questions, sir?
Yes, sir. One question is, you talked about the moisture-free environment. So I was just curious how you elaborated and eliminated the moisture that is present in the pellet.
So there was some disturbance. Please repeat it.
Mr. Soumyadeep, I request you, please keep yourself on mute.
You just elaborated in the PPT that you created a moisture-free environment. While
I would like to reiterate, sir, we make sure that the trucks which are carrying the pellets come to us fully covered with tarpaulin. We remove the tarpaulin only for taking samples from one side, until the truck is there, till it is unloaded by truck to truck, the tarpaulin is there. Only prior to only after getting clearance from the chemistry department, that we can go ahead with the unloading. We remove the tarpaulin. So for most of the period it is all covered. Then it is immediately unloaded and it is fed to the bunkers. So that way the period when the material is in the open atmosphere is very less. That is why moisture pickup can be controlled. And as I already said, that as soon as we load it, we make it a point to consume.
Sir, as soon as the pellets are received, the chemistry department is giving clearance on the basis of moisture.
Yes, sir.
But the GCV is checked later.
Yes, sir. GCV is checked later.
So we are not taking GCV as a criteria for rejection or accepting the pellets.
Sir, because in case we take GCV also, it will take more time to analyze. So first and foremost, we go for moisture only, and the GCV and all is checked later.
So whatever amount we are taking for sample, that same amount we are using for moisture as well as GCV later, no?
Yes, yes.
So one more question.
Please, sir.
Sir, after taking all the precautions, did you have experienced any fire hazard?
Sir, nowadays we are not having any fire hazard since we took the required precautions. But when we started in 2017, I think at that time there must have been some of the other small issues which were overcome. As I said in my presentation itself, that in the initial time there were some hiccups. Sir, I think the next presenter is waiting.
Yes, sir. Sir, we thank Subhash Kakkar, sir, for giving us elaborate idea on the economies of the biomass, using biomass pellets, what are the challenges and how to mitigate them. Thank you so much, sir. Now I would invite Shri Ashwini Kumar Verma, Senior Manager from NTPC. He would be also delivering on the journey of the biomass co-firing. Ashwini sir, you are welcome on this platform, and over to you, sir.
Okay, thank you. Thank you, Environment. And namaskaram to all.
So today's this my presentation is visible
Yes, sir.
and I am audible, na?
Yes, sir.
Okay.
Sure.
Right. Right. So this is the basically this presentation is about coal biomass co-firing to accelerate the energy transition. So I will start from the electricity scenario in India. So, so basically this is the electricity scenario in India, and I would like to mention about the commitment of India in COP26. So the commitment of India, everybody is knowing that India has committed to reduce the carbon percentage from non-fossil based capacity like wind, solar, biomass, everything, whatever is non-renewable. So that is the action plan of India. So biomass is going to play a very important role in that, and how it is going to play in an important role, we will see in the next slide. So what is the importance of biomass in energy transition? So can we say that a primary source of all kind of energy sources such as coal, oil, gas, hydro, wind, solar and biomass on this earth is sun? Can we say that? So basically we can say that the primary source of all these energies are sun. Why? Because hydro power is just and is another form of sun. Solar power is direct form of sun. Wind power is also a form of sun because it blows due to the temperature difference created by sun only. Temperature difference and temperature difference create the pressure difference. So due to that, the wind blows. Hydropower because just because of sun, water evaporates from the ocean and gets deposited on the mountain, and from there the water comes back on the lower elevation, and accordingly the hydropower is generated. And even when we talk about this coal is also a form of solar energy because coal is nothing but is solar energy in storage form. Coal is basically biomass which was got under the earth thousands of years before and got torrified by the high pressure and temperature. So it becomes like coal. What is oil and gas? Oil and gas is nothing but it are the some oceanic creations like fish, plankton, etc., which gets under the earth crust thousands years back and gets converted into the oil. So this is basically the solar energy in storage form. But how this biomass is going to be different from all of these? Because coal and oil is basically the carbon sequestered by the nature inside the surface of earth. So when we sequestered the carbon, so we remove some carbon dioxide from the environment. So again, when we will release it, it will create the greenhouse effect. But in case of agriculture residue biomass, in case of agriculture residue based biomass, what will happen that the amount of carbon emitted will again absorb back by the next crop cycle, and the net amount of CO2 in atmosphere will not increase. So basically this question is asked multiple times that how biomass is renewable. It is also emitting CO2, so it should not be renewable. So this is renewable like that because we are planting the crop every time. So whatever the amount of CO2 we are releasing by burning the agriculture residue, it will be again get reabsorbed in the next crop cycle. So by this method, it will remain carbon neutral. So what we can see, conclude from this slide, that hydro has limited potential in view of dependence on a specific location. So we cannot put hydro every location. India has already 45 gigawatt of hydro, and there will more come. How many hydro comes, it is better, but there are limited potential. Solar and wind have seasonal variability. So because of this seasonal variability, storage is required. So India is already working on that. And with biomass, it is available around the clock. As you have said, seen in the previous presentation, that it is available round the clock, and it is at the cheapest source of biomass, round the clock biomass. So it will always get first priority. So that is why the government is so much behind this biomass, because it's the cheapest kind of renewable. It is even cheaper than solar and wind, when energy storage cost is also taken in account. Because when we talk about the solar and wind power cost, we can say that it is almost 2.5 to 3 rupees per unit. But actually, to make it round the clock, energy storage is required. And when we couple energy storage with the solar and wind, the cost went up to 12 rupees, 15 rupees, in that range only. So, so that is the actual cost, true cost of RE. So when we say about tell about biomass, so biomass cost is almost in ranging between 5 to 7 rupees per unit. So in comparison to wind and solar with storage, biomass is always cheaper. And in comparison to hydro, it is double costlier. But in case of wind and solar, yes, it is cheaper. And currently, when we talk about hydro price is also in range of 6 to 7 rupees. So it is comparable. So that is why there are so much stress on biomass, and it is going to play a very important role in the energy transition. And just by replacing some fuel in the coal power plant, we can reduce the carbon percentage by 10 to 12%. Currently it is 10%, we can say, but we are trying that in future we can reach up to 20%. So that effort is already on. So these are some key highlight about the biomass. So as I have already explained, that equivalent amount of CO2 emission from combustion of agricultural residue from sustainable sources is absorbed in next crop cycle, which makes it carbon neutral fuel. So this is sustainable sources, because we do cropping again and again. And it is also applicable for sustainable foresting. So it may be the next initiative. Sustainable foresting means we plant the forest on some wasteland, or we plant some crop on wasteland, and we harvest that to utilize is in a form of to utilize for energy purposes. So that may be the next step. So that is also renewable. But when we will cut trees and we will not plant it back, so definitely it will not be renewable. So making it sustainable is important. Second thing, biomass is solar energy in storage form via photosynthesis and is dispatchable around the clock power. Third, biomass co-firing is recognized by UNFCCC as a technology to mitigate GHG emission. It may contribute to the NDC goal of India. Third, ash produced from its combustion in furnace is absorbed in electrostatic precipitator of power plant. So it reduces pollution due to stubble burning. So what happens when we burn a stubble? Pollution is basically created due to this ash and soot. But here when we burn it in plant, so this ash is get absorbed in the electrostatic precipitator. So the pollution and so whatever the flue gas comes out from the chimney, pollution level, the level becomes under the statutory limits. That is why we can say that it reduces the pollution. And fifth point is it is cost competitive with solar and wind if indirect cost is of integration or energy storage cost is also taken into account. So this is about the journey of biomass co-firing in India. So basically it started way back in 2017, when there was a huge pollution due to stubble burning in Delhi NCR region, and the government of India called all the stakeholders, including IOCL, NTPC, BPSL, all over stakeholders, to suggest some solution to utilize this biomass for energy application. So we conducted all those studies, and we concluded that yes, why this stubble burning is there, because it has no alternate utilization. And if it has no alternate utilization, that it will have no value. When it will have no value, so definitely the things which has no value in the society get destroyed. So how we can create the value to the biomass, that was the main problem, main area of our deliberation. So yes, by the use of for energy application, we would be able to create some value to the biomass. But what could be the method? So that was the first question. So someone say that a decentralized application is good. Use the biomass in decentralized form, then it will be most economical. And someone says that a biomass co-firing is option because in European countries and Japan, this biomass co-firing was used to be the most economical option. So we studied the both the scenario and we prepared this comparative chart. You can see what is the comparative chart, and we concluded that the tariff in case of biomass co-firing is always lesser than dedicated small biomass plant because of high efficiency. Even if we price the pellet and it becomes a costlier affair, the cost do not goes high. So the biomass co-firing proves to be the economical than decentralized dedicated biomass. And the third thing, this operational issue. So in the case of dedicated small biomass plant, the feedback was the frequent shutdown due to slugging and fouling. But in case of biomass co-firing, there was no such issue because we were using biomass in very small quantity, say 10%. In 10%, the main slugging and fouling corrosion causing element, alkali chloride, get diluted. So in dilution form, it don't cause any slugging, fouling, corrosion issue. So biomass co-firing also gets lead in that on that aspect. Fourth aspect, biomass fuel risk. So feedback was there that when we installed this dedicated biomass plant, so there was so much fuel, but after some time, farmers started blackmailing that just hike the price, then I will give you the biomass plant because they are seeing that this biomass plant is there. So anyway, you will pay price for that. So there is biomass fuel risk because it is the primary fuel. But in case of biomass co-firing, we will bring a secondary fuel. When it will come, we will fire. But anyway, due to any force majeure thing, it did not come, and there is no such compulsion. And energy yield using some amount of biomass, same amount of biomass. So in case of biomass co-firing, we will always generate double amount of renewable power in comparison to dedicated biomass because of higher efficiency. And project duration, you can say that small biomass plant 2.5 years to 3 years, and in case of biomass co-firing, we can be prepared within 15 days to 3 months period. And further aspect is the requirement of separate infrastructure, separate PPAs, statutory clearance, and additional manpower. Everything will be required in case of dedicated small biomass plant. But in case of biomass co-firing, just we have to replace the fuel, so all these things will not be required. So due to all these reasons, we selected this biomass co-firing is the optimal option. Now, some question was raised later that okay, all right, you choose the biomass co-firing, but we are collecting it from the fields, we are emitting some carbon, and again we are pelletizing, and we are using around 100 units of electricity, 100 units electricity per metric ton of biomass. So how it will be remain carbon neutral? Just calculate that at least we are not emitting more carbon, that we are saving the carbon. So we just did this calculation that how much amount of diesel we are just consuming for the collection of biomass. So this amount comes to 3 liters a ton. What amount of CO2 emission? This is 8 kg. Further electricity consumption for pelletization 100 kilowatt hour per ton. So how much carbon emission we are doing? 80 kg. The total CO2 emission in both the process 88 kg. So hardly we are emitting 88 to 100 kg of CO2 to manufacture 1 ton of pellet. So but how much we are saving? So we are just replacing, because GCV of biomass and coal are same. So we are replacing equivalent amount of coal. So just by firing 1 ton of coal, how much CO2 we emit? We emit 1428 kg of CO2. It also depends upon the efficiency, but a typical figure is 1428 kg of CO2 we emit. So when we will replace the coal with biomass, so this much CO2 we will be saving. So how much is the net gain? Net gain is 1320. any means 94% it is renewable, only 6% we are emitting. So it is basically lowering the CO2. Further, diesel consumption in the case of transportation, it is around say 1,000 kilometer transportation. So it is 30 liter a ton. How much emission? 86 ton, 86 kg. So it is also not a very high figure. So even we transport to 1,000 kilometer, we are actually saving more CO2 than we are releasing. So basically we are net we are reducing. So it is acceptable. Further, we should not take this transportation component into account because we do the same thing in the coal. For the calculation of coal CO2, we don't take transportation component. So we can ignore this figure, transportation component. So basically, our two figures will prevail. So when we do this carbon neutrality test or biomass pellet, it will always be found to be reducing the carbon, irrespective of we are transporting it to 1,000 kilometer, irrespective of we are pelletizing it, irrespective of we are just collecting the biomass from the fields. The amount of carbon emission from all these activities will always be far lower than the amount of carbon we are saving. So this is the conclusion.
Good afternoon,
So how much biomass potential is available in India? So you can see here that and you have also known from the previous slide that the total amount of agriculture residue generation in India is around 754 million tons per year. So this much agriculture residue is generated in India every year, and almost 600 million tons per year is the amount of coal we fired for the energy application, and GCV is equivalent. So we can think that if we utilize whole biomass in the coal power plant, so we can 100% replace the coal, but it is not going to happen. Just hypothetically, I am saying that it can. So to give the just idea how much amount of biomass is generated. So it is almost same quantity that we are using coal. So both quantity is almost equal, but we are not going to utilize 100% because almost 70% has the market value, and it is being utilized as an animal fodder in traditional applications. So almost 70% are being utilized, and just 30% is surplus, and because it is surplus, it has no market value. That is why it is being burned, and this surplus has huge potential. How much potential? It can generate almost 325 billion units of electricity, which is almost 25% of India's electricity consumption today. So it has huge potential, and it can replace up to 20% coal. But right now we have proved that up to 10% there is no issue. Up to 20% we are working. So this is the potential. And how much CO2 emission we can reduce? 325 million metric tons CO2 we can reduce. So basically this is the process of complete biomass collection to the pelletization. So basically there was a time when people were saying that how much biomass is available, how we will pelletize, how we will collect it, how we will pelletize, and how will come to field. So it is the pictorial depiction of everything. It is the cutting, packing, baling, stacking, storage, processing, and pelletization, then transportation by truck, then biomass feeding into the power plant, biomass conveying, biomass co-milling, and power generation. So these are all the steps. So initially when we started this biomass co-firing, so there were multiple challenges we have identified. So the technical challenges was high volatile content, high alkali and chlorine content, low ignition temperature. Low ignition temperature means the ignition temperature of biomass is 250, which is far lesser than coal. Fibrous nature of biomass was not brittle nature. OEM clearance, ash utilization. So these all were the technical challenges. Second challenge was earlier when we started there was no vendor base. Vendor base challenge was there. Logistic infrastructure was there. When we did our first UI, not a single party responded in that UI. Later we searched on IndiaMart, we got some handful of parties, we directly contacted, we did an UI. So we go through all these processes. And third challenge was commercial challenges. Earlier, they were saying that biomass is costlier than coal, so it will not make a business case. And further, the APC and hit rate will increase during co-firing. So how it will be taken care in the regulation itself, and there is no policy and regulation was in place earlier. So it was the commercial challenges. And fourth challenge was network and capacity building. So pellet manufacturers are not aware of NTPC requirement. Gencos were not aware of biomass co-firing technique. Lack of confidence among the financial institution. Even today, the banks are doing all the due diligence. They are very much doubtful and suspicious about this biomass business. So creating that confidence is required, and lack of networking among the stakeholders. So all these were the challenges. So how we overcome that challenges? We are saying telling about all these things because same challenges will come to other gencos. So they will start asking for exemption. So exemption will not work because it is the government national mission. So how we can make it successful, that is important. And we float some UI or tender and we get no biomass, and we can say that see that we have floated this UI and there is no biomass in the market, there is no biomass in vicinity. So this problem will always come. Same problem has come to us. But how we can sort out those problems, that is important. And these are the initial teething trouble. And after some passage of time, we will see that yes, gradually the capacity building will be there. Today there is some X amount of X numbers of biomass vendor, and after 1 year there will be 2x, 3x, and the numbers will increase exponentially when people will see the profit in the business, and banks will also have the confidence in the sector. So all these things will come with time, but we will have to continuously do all these things. So how we will just overcome these technical challenges, I will tell you. So these are we just compared the characteristic of this bituminous coal and paddy straw. We saw that volatile content and fixed carbon ratio is just opposite. Volatile content in biomass is higher, fixed carbon is less. Ash content is less, moisture almost comparable, GCV comparable, alkali content it was one of the culprit to which can increase slagging fouling. So it was 6 to 8%. Chloride content it was higher, and ignition temperature it was very far lower, 240, and nature was fibrous. Ash fusion temperature was very less. So we did some pilot experiment, some lab experiment. Our NETA did some lab experiment, and we will know about in next session that NETA did all this experiment and told us that up to 10% there is no issue with respect to slagging, fouling, and corrosion, and we can proceed with this 10%. Second, we will have to reduce the mill inlet temperature. So these two input we get from our R&D wing. So we just move ahead with these parameters. So we identified what are the ways to fire biomass. We did some international literature study, and we found that 100% biomass pellet milling in coal mill is also possible, but it can be done when we require to achieve 100% biomass co-firing, 100% biomass firing, as is the case in the DRAX. They are firing, but for 100% biomass. And second option was co-milling of biomass pellet. So for low co-firing ratio of 10%, this method was suitable, and we selected this method. One method was also there, the dedicated biomass milling, and it was achieved to achieve higher co-firing ratio in combination with wood and agro residue-based pellet. So, but we don't go with this option because our ratio was up to 10% only. So option 2, that is dedicated co-milling, co-milling was the suitable option. So we selected accordingly. So what is the challenge with agricultural residue, and what is limiting factor for 5 to 10%? That is low ignition temperature, high volatile content, fibrous nature, causing difficulty in milling in high ratio, low ash fusion temperature, and slagging tendency due to high alkali content at high ratio, corrosive tendency. So to overcome all these challenges, we limited its percentage.
And here we can, in graph, we can see that this is the deposition rate, means you can say slugging index, gram per kg. You can see the scale. This is 0.01, this is 100. So this is the scale. So in case of wood, alkali and chlorine content is very less. So in case of wood, wood can be fired 100%. But in case of agricultural residue, you can see the deposition rate is 1000 times high. 1000 times high. You can 500 to 1000 times high. So deposition will be huge when you will co-fire in high ratio. You can say 100%. But that is why we are not going to fire in high ratio. We are limiting to 10%. So up to 10%, there is no issue, such issue. We have experienced that we are co-firing for a long time. We have not experienced any issue, even in overhauling. There is no such any problem on the boiler pressure part tubes. So up to 10% co-firing, it is absolutely safe. So this is how we did the blending. We will see it in detail in the next session. So these are the co-milling operation procedure and impact on boiler performance. So how we achieve this biomass co-firing? So stimulating valve is given in every mill, but it remained defunct. So we made it live and given the remote operation, make it the remote operative. Second was modulation control of hot air damper and cold air damper was provided from mill inlet temperature. Normally it is control was provided from mill outlet temperature, but we shifted the control to mill inlet temperature. And mill inlet temperature was limited to 175 to 180 degrees centigrade. Why? Because in this temperature range, volatile matter releases from biomass, and we know the system is pressurized system. So when volatile matter will release at high temperature, so volatile matter will escape in the environment and we will lose some GCV. So mill inlet temperature will require to be in this range. Further, mill inlet temperature high alarm was provided 190 degrees centigrade. Temperature sensor were installed in each pole pipe. Mill outlet temperature high alarm was given at 70 degrees centigrade. Illumination inside feeder was done to see biomass is coming in or not. Because when biomass will not be on feeder, we can increase the mill inlet temperature. So to verify that, and primary header temperature kept above 800 millimeter water column. Why? Because the biomass is fibrous nature, so it will be polarized, but it will not downsized in the range of cold, that is micron. That is why, but it will have less density, so obviously it will pass through the classifier. But to make it happen, some high pre-header pressure will require to be maintained. So after doing all these things, we monitored some parameters like increase in exit flue gas temperature, 7 degrees centigrade, during co-firing, increase in some power, mill power, and fuel handling system. So due to all these things, so overall decrease in boiler efficiency was observed in the range of 0.33%, and increase in unburnt carbon bottom mass was observed in the range of 10%, and decrease in unburnt carbon was also observed in fly ash to 10%. So net it was a decrease in unburnt carbon. Right? In the boiler efficiency, it is affecting the boiler efficiency by 0.33%. So we did the policy advocacy that we need the compensation for this decrease in boiler efficiency. So accordingly, the policy was prepared. So this is about the effect on boiler performance. And after doing biomass co-firing, we can inspect the mill after running half an hour, so that accordingly we may do the classified setting if there is some settling inside the mill. But in our case, no such issue was encountered, and biomass was pulverized well with the coal. Not such issue was encountered. Safety aspect. So in view of fire-prone nature of biomass, fire tender and fire fighting system may be kept ready in advance when you are going to fire first time. Continuous monitoring of mill parameters, which inlet temperature, mill outlet temperature, mill current, DP is recommended. Pre-start and post-shutdown mill purging must be done. Monitoring of mill and its reject system must be done intermittently. Clinking and slagging tendency to be observed from local as well as from
presentation of Ashwini Verma will end. After that, you will start.
Rise in flue gas temperature, because when there is slagging, so flue gas temperature increased. So why that we can analyze if there is slagging or not. But actually it will not happen. We have not observed, but it can be kept under observation when we are going to fire first time. Should blowing an LRC should be done accordingly, and during test firing, no such tendency was observed. Further, there is one more concern about ash utilization. People say that as per ASTM, the 100% coal ash can be used for the cement application, but there is experience in Europe. They have also started biomass firing, so same problem also came there, and we can see there that they were having a norm EN 450, and they revised that norm, and we can say that after co-firing experience in Europe and analysis of ash generated from co-firing, original European EN 450 standard was revised, and now European EN 452 standard specified that fly ash from co-combustion of specific secondary fuels such as wood chip, straw, olive peat, other vegetable fibers, green wood, cultivated biomass, etc., can now be used for concrete provided the percentage of secondary fuel does not exceed 20% biomass, and if derived amount of ash from the co-combustion material is not greater than 10%. There are additional limits on static chemical properties of ash, such as chloride content has to be less than 0.1% and total alkali content should be less than 5%. The chloride levels in grass and straw in worst case allowed the co-firing up to 10%. So up to 10% there is no such issue, and accordingly the norm in India is yet to be revised. It can be revised on suitable opportunity. So accordingly, after all this initiative, finally the national mission came, Samarth mission came on 25 May 2021. The objective was the mission was you know everything, and the policy it has already been covered in a previous session. What is the policy? Just to highlight a few points that currently it is a mandatory use of 5% biomass in all the coal plants, and in case of reserve shutdown, effort will be to co-fire up to 10%. Exemption if applicable on case-to-case basis. Policy will be enforced till 25 years and till useful life of power plant, which was earlier. Biomass co-firing limit to be reviewed time to time with the advancement can be increased. Provision for long-term biomass pellet supply contract with annual price increment as per terms and conditions to enable supply chain. It is very important. Increased cost due to biomass co-firing shall be passed through and can be claimed under change in law. No impact on melt order dispatch due to biomass co-firing. It has already been clarified. It is very clear in policy. And DISCOM to get RPO for purchase of biomass power. So from DISCOM side, no issue because they are getting cheapest renewable power and also getting RPO at the same time. So DISCOM will buy that electricity even if cost is increased. So business case is there with the help of this policy support, even if cost of biomass is high. So from business point of view, there is not any issue. What is the expense of biomass co-firing in NTPC? So almost 80,000 metric ton biomass pellet has been co-fired till 10 July, and we have already placed the purchase order for 12.35 lakh metric tons for 20 station, and further work is under progress. We are going even beyond that. This is the biomass torrefaction alternate for high degree of co-firing. We are also exploring that method. This method can allow us to co-fire in high ratio, and we are also exploring how we can reduce this alkali and chlorine content in future. When we will be able to reduce this alkali and chlorine content, we will be able to achieve a very high amount of biomass co-firing. But currently, we can say from lab experiment, we can say up to 20% with torrefied material is not an issue. We can achieve that. Third, this is commercial aspect. So commercial aspect, option 1, option 2 has been shown that how this should work, and this is basically the policy advocacy, and we are also proposing that incentive for biomass co-firing should be given rather than making it mandatory. So lump sum amount of per ton of biomass co-fired may be allowed to GenCost to add into the price of tariffs for calculation as incentive. Suppose biomass is costing 8,000 rupees a ton. So we can be allowed that we can add some lump sum amount, suppose 500 or 1,000 rupees to get some incentive and to cover all these losses, everything. So when there will be some revenue, then definitely people will co-fire. So this is basically in policy advocacy phase, and mechanism may be devised to a certain amount of biomass co-firing, so that transparent and clear-cut mechanism should be in place. And this is the way forward. So biomass co-firing methodology needed policy support has already been developed to kick-start the sector, and national mission has already been set up. 5 to 10% co-firing ratio using agricultural residue has already been achieved by NTPC stations. However, for beyond 10%, study is underway for improving agricultural residue fuel properties. Method of reducing alkali and chlorine content is under exploration to enable higher co-firing. Creating large-scale biomass collection and processing infrastructure is key for success of national mission, and building confidence among stakeholders of complete business chain, investors, banks, GENCOs, DISCOM is need for rapid proliferation. And incentive per ton of pellet may be given to kick-start the sector while making a good business case. Thank you.
40 है फिर भी मैं
If
कोऑर्डिनेटर
there is
से
any
पूछ कर
question, you may
बता
ask.
देती हूँ, ठीक है?
Thank you, sir.
Okay, sure. Okay. Thank you.
कोई क्वेश्चन है आप लोग पूछ सकते हैं.
Sir, this is Gautam Sarkar from STPS.
Yes.
Hello. Sir, what are the components within the biomass pallet? One of them is agricultural residue and others are
Others are agricultural residue. This wood pellet is also there, counted in biomass. So wood pellet is also there, but it should be obtained from sustainable sources. So you can Google and see the wood pellet obtained from sustainable foresting. So this is used in European countries. So it is there.
is cow dung is used for biomass?
Cow dung can also be used, but why will apply cow dung? Because cow dung can better be used in this farming application. We are using this agricultural residue because it has no alternative market. That is why we are using it without harming the environment. Because when we will burn it in open field, so it will create some environmental issue. That is why we are using plant. But with cow dung, that is not such issue.
How the agriculture residue is mixed with something, and it will create pellet. What are the other components used for the agriculture residue?
Pardon?
What are the other components used at agriculture residue to make it a pellet?
Not any other component. Basically, what vendors use, some people use binders, but in a biomass, lignin is present. So lignin is get secreted at higher temperature when it gets placed in the dye. So lignin helps in getting biomass binded. So this is all used. And further to pelletize the biomass, it is first downsized up to 5 mm or say 3 mm, 1 mm level by using hammer mill. So after this downsizing this biomass, we pelletize it. Any more question?
Any questions?
Can you hear me? Yes, बताइए मनीष जी.
What is the rejection percentage during a month?
Rejection percentage?
For you have tested the material before unloading, for test analyzing the total moisture. What is the rejection percentage you have during the month you observe?
So far we have not got any this rejection experience. So whatever biomass comes, we tried that. But this question will be well answered in next session because our fellow from Dadri will be there. So all these queries from the site experience will be answered by them.
Okay. Thank you, sir.
Okay. Okay. Thank you. Thank you very much. Thank you.
Uh, Thank you, Ashwini sir. Thank you for the wonderful presentation on the coal biomass